Hello and welcome to the very first C# 101, an introduction class brought to you by 3dbuzz.com. Your lead instructors for this class will be both myself, Jason Busby, and Nelson LeKay. Say hi to everyone, Nelson.
Hi, everyone.
All right. So there's a few things that I'd like to go over first. And the very first one is what can be expected. Well, the prerequisites, this is a class that's designed for complete beginners. I really don't want to stray off onto tangents in class for those of you that happen to know more about C# than your complete beginner and you start asking questions that go outside of the scope of the syllabus. The problem with venturing down those tangents is that it can quickly confuse those that are trying to learn C#. So Nelson, please keep that in mind. So let's try to keep things focused. That does not mean that you guys cannot PM us questions or post them in the forums, or even if we're on break and students are off getting coffee or whatever, feel free to of course talk to us in chat there and ask your questions. But outside of that, I'd like to try to keep it as focused and on topic as possible. Also, by now you should have downloaded and installed Visual Studio 2010. Visual Studio 2010 Express will work just fine for everything that we're going to be doing in both the 101 class, 102, 103, and so on. So just make sure you get it installed. If you have Pro or any of the other editions, of course, those will work fine as well. For those of you that happen to be on other platforms, such as Mac, you can use MonoDevelop. I do know that we have people that really would like to learn the C# language and don't have access to Visual Studio. That's okay. You can follow along with MonoDevelop. We're not supporting MonoDevelop for the simple fact that if we're having to deal with different IDEs other than Visual Studio, things could get messy real quick. Now, since this is a 101 class, you should be able to find everything that we are talking about in this class with no problem in your own IDE. So it shouldn't be that big of a deal. Let's see, what else? That prerequisites, that's pretty much it. Homework, there are going to be assignments that are going to be given out at the end of each of the classes, and they're expected to be submitted 2 days prior to the next class. Now, when I say the next class, I'm referring to, like, this is a Monday class. So the official next class for this one is going to be next Monday. So don't let that become confused with the Thursday classes. So homework submissions, for now, what I'd like for you guys to do is simply zip up or attach your CS files, your project, and just send it on over to me. Use my email address, busbyj@3dbuzz.com. So again, busbyj@3dbuzz.com. So it's just like my username over on 3dbuzz with @3dbuzz.com at the end. Gavin, who is joining us in the class today, is going to be our awesome TA as we work our way through this particular 101 class, and he will be helping with grading homework assignments and providing feedback, etc. So everybody say hi to Gavin. So let's see, what else? Certificate. This is a certificate-based program. Now, there's a few things that we've discussed around the office over here in regards to participation and what's required to actually get the certificate. You need to attend at least 50% of the classes. So that's not bad. I mean, we're holding the class on Monday. We're holding it again on Thursdays at 2 different times to accommodate people around the world. And 50%, that means you can miss, 3 of the classes. Now, you don't have to, it does not have to always be Mondays or always Thursday. You might come, Monday this week, Thursday next week, Monday the week after, and then if you don't attend any of the other 3 classes, that's fine. But you have to complete all of the assignments, which means you'll need to go back and review the videos once the videos for each webinar has been posted. So that's pretty important. By taking care of all of that, once the class is over, Nelson and I will both sign a completion certificate for the 101 course, in which it will be delivered to you via email most likely. And it'll be your responsibility to get printed out. The only other thing, which as you guys all know with today's delay in class start, is BuzzNet. BuzzNet after today, if we can get everything worked out before next Monday, which we should be able to, it is a required application. And I say that for the simple fact that the GoToWebinar does not provide us with a lot of security. And with BuzzNet, we are able to make sure that everyone that is logged into the class, that they're actually member sponsors by simply comparing both the people that are logged in BuzzNet with the people that are logged in with the webinar. I know that's pretty lame. Unfortunately, that's all they've given us to work with, so that's what we'll have to do. Plus, we also are giving you guys the flexibility of coming and going as you'd like, and again, that keeps things a little bit more muddied for us as well. And so, again, just trying to keep things as simple as possible for us in regards to keeping track of people. So BuzzNet will be required. Also, with BuzzNet, you have the ability to click the Participate button. I do encourage everyone to, well, participate. That's really important in learning this stuff if you truly are a noob. And with it, there is the ability to tell us to hang on one moment or you're ready to advance forward, and we will simply use that in regards to telling if everybody's ready to go forward, and that'll keep things running a lot smoother. So that's pretty much all I had to say in regards to what can be expected and what's required. And so from here, the next thing I wanted to do is go ahead and jump over to a little discussion about an IDE. So Nelson, you want to talk a little bit about what an integrated development environment is?
Yeah, basically, when you write software, well, at least in the modern day, you need a set of tools in order to write that software, and an IDE provides that. An IDE, you can think about it just like just any other tool that you might have to accomplish some sort of task, but in this case, the task is going to be to allow you to program easier. What it really does, what makes an IDE stands for Integrated Development Environment, is it brings together things like the compiler and the debugger and all these miscellaneous tools that aren't very user-friendly, and it presents them all in an integrated, user-friendly way that you can go from end-to-end development, from starting your application to writing code for your application to testing your application to even deploying your application is all going to be handled in an IDE. The IDE that we're using here is Visual Studio, or Visual C#, I guess you could say. And yeah.
Pretty simple. I mean, you could write your code in Notepad without any problem,
yeah,
right?
Certainly. Really, for C#, the only requirement to go from C# source code to a program that you can actually run is that you pass your C# source code into the C# compiler, which is a program that comes with the .NET framework itself. It's just this little console application that you can send files to, and it spits out a program for you. And IDE, the Visual Studio, is basically just a huge wrapper around that, and it provides a really user-friendly way so you don't have to deal with doing the compilations manually, and you get nice features like syntax highlighting and code completion and all that stuff. Mm-hmm. So
one more thing that I had jotted down in regards to using Visual Studio before we end up getting into code, and that'll make it easier to demonstrate stuff, but that is concepts of a solution and project. So you want to talk about that for just a moment?
Sure. Do you want me to go ahead and have everybody create a new project, or?
Yeah. Go ahead and have everybody create a project. That's absolutely fine.
Alrighty. So I'm going to go ahead and hit this new project button. I reset all your ready statuses, by the way. So go ahead and hit a new project and select a console application and hit the OK button. So is everybody good up to now?
Yeah, it's very nice being able to watch the admin screen.
Yeah, I was about to say that's
quite handy.
It is. Oh, come on, Toastage. So I take it there might be a few people who don't have Visual C# installed, or it takes a while. Yes, it does take a while. What you're seeing right here is a fresh install of Windows 7 with a fresh install of Visual C# on inside of a virtual machine, and yeah, as a result, it's going to run snappier than Visual Studio usually runs, which is quite horrid.
Which I do hope we see a much faster 2012 than we did with 2010.
That's what people are saying. I can't wait to try out the beta later this week.
I know that a lot of people have been screaming about the speed of Visual Studio for quite some time. So that's a very nice thing for them to address.
Those with Pro might need to pick C# from the list. Yes, make sure that if you are using a Pro version of Visual Studio that you select the C# programming language from the new project window. Yeah, it looks like a lot of people are having difficulty with the speed.
With the speed of it starting up or starting the new project?
Probably both, considering Visual Studio.
So, go ahead.
Mary, you're going to want to, here, I'm going to open up another window so you can see it. There's a button on the top left, generally, when you start up Visual Studio or Visual C# 2010 Express. Go ahead and hit that new project button. Make sure that you have Visual C# selected here. Now, if you have the Express edition of Visual C#, you're only going to have one option, but if you have the Pro version, it's going to be quite a few options. Then make sure you select a console application and then hit the OK button. And at that point, you'll have a screen that looks like what I have up right here.
Yeah, Enrico asks if 2012 will have the achievements and trophies and stuff, such as, congratulations, you have achieved, achieved, compiled your first program?
Yeah, I don't know, actually. I know they added the achievement plugin to 2010.
Now remember, guys, once you have this complete, make sure to check off the "You are ready" in your BuzzNet app so that we know that everybody's in good shape.
Yep.
There we go.
We definitely are watching that. And
yes, we are. Almost everyone. Here we go. We're at the very end. Just a couple people left. And Gavin's right, Nelson. You can go ahead and show the file new project in case they do not have the start screen available.
If the start page doesn't start up or you close it for whatever reason, you can go to File and then New Project. If you're in a Pro version, it's going to be File and then like New Something, and then you have to go into Submenu. But either way, it'll be under the File menu. And so my screen should look basically exactly like your screen, hopefully, because this is a completely fresh install. Or just go to, or you can go to View Start Page to get that again. All right.
So we've got Bush AV8R. Is everything good? If so, go ahead and check the ready button, and I think we're ready to go forward.
Yep. If not, definitely ask a question.
If something.
And we can answer that. Yeah, it's the green flag.
Yep.
You're going to have to double-click on the window. I'm going to fix that soon.
Sweet. All right. Awesome. So our first task, everyone has successfully checked off the participating complete. Okay, Nelson, so solution projects.
Okay, I'm not going to talk about Program.cs yet. So go ahead and close Program.cs if that's scary. What this is you have over here on the right-hand side a Solution Explorer. And the Solution Explorer is a view of your solution. All of a solution is a collection of projects. All a project is a collection of code files. So there's a hierarchy that you can even see represented graphically right here, where we have the solution, which is the highest level concept in Visual Studio. A Visual Studio window may only have one solution open, and it's going to be whatever solution that you either opened or created. Underneath your solution, you're going to have the individual projects that constitute your solution. A project, you can think about a project as one unit of compilation, meaning when a project is run through the C# compiler, it will generate one file, whether that file is a DLL or executable file that you can run. So a solution might, a typical solution will contain many DLL projects and then maybe one or two executable projects. And if you were to tell Visual Studio to compile all of your code, every project will correspond to one output file. Underneath your project, you have the individual source code files that represent your project. That was kind of redundant, but every source code file that is compiled by Visual Studio has to exist underneath a project. You can put free-floating files inside of a solution if you really wanted to, but typically you're going to see .cs files underneath your project right here. So remember, solution is the overarching idea of Visual Studio. You open up solutions, you compile solutions, blah, blah, blah. And then underneath solutions, you have a variety of individual projects underneath that solution. We're not going to necessarily be talking about creating multiple projects underneath a solution yet, but if that's why the separation does exist between a solution and a project.
Okay, very good. And for those of you that have followed along with any of the Nelson Corners or any of the other C#-based, more advanced projects that we have done, I'm sure you have seen multiple solutions that contain multiple projects.
Yep.
All right.
It's a very handy way to, there's a variety of reasons why you might want to do so.
So, Nelson, let's see. What do I need to do to kick screen back over this way? Let me see if this will work. And let me tell you. Do what?
Aww.
Show my screen. Why are you getting sad, Nelson? Well, I mean, if people don't want to see my screen, that's okay. I'll just talk for a minute or two.
Oh, your Visual Studio is terrifying.
Why do you say so? Oh, because of I haven't done any sort of reduction or anything like you've done, so I still have everything still installed. All right, guys, let me go ahead and do a file, new project, so that I'm caught up with everyone. And I'm just going to leave it named, default name, so console application 2. See, Nelson, I usually name mine. And let's write our first program real quick. So here's the first thing I'm going to do, and I want you guys to do the exact same thing. Highlight everything that is inside of Program.cs and hit delete. I want it gone. Gone, 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 gone. Yes, Wolfery. Gasp. Okay, so I'm also going to reset the ready checks for everyone because we're going to type out something nice and simple. And let me see what size this is going to be. Hang on one second. Let me get a little bit larger. There you go. Everybody should be able to see that with absolutely no trouble. Now, case sensitivity is extremely important when working in the C# language. So I'm going to go ahead and make my program capitalized. Though make sure that you follow the case sensitivity that I use, or you will definitely run into problems. Now with class program, up underneath it on lines 3 and 5, you'll see that I have an open curly brace and a closing curly brace. Nelson, do you want to walk them through real quick for those that are interested in turning on numbering? The numbers in the editor?
Well, it might be easier to show it, but...
It's up under, where's our...
It's going to be under Tools, left. There you go.
And,
Options.
And Editors.
It's going to be under Text Editor. You're going to want to expand that.
Yeah, and go to...
You can either do C#. Generally, what I do is go under all languages, and then you're going to have line numbers under Display on the right.
So again, let me do that nice and slow, since you see I do that about once every 3 or 4 years. So up under Tools, go down to Options, and then from inside of Options, simply drop down to Text Editor and expand that. And you can go to just all languages and simply check line numbers.
Vern S., if they tried, they probably could.
I'm sure they could. And then just click OK. And that should give you what you're needing.
If you have no all languages, go ahead and select the C# one. I'm not actually sure. See, I don't think I've ever used the Express edition of... Yeah, the Express edition will only have C#.
Okay.
So then if you're under the Express Edition, go under Text Editor, C#, and then under Formatting and General. No. Wait, what? Can you even turn line numbers on with this?
No way.
I'm not seeing the option here.
I've used Express before with line numbers. I know I have. We did in the XNA class. I'm sure we used Express in that.
I don't see it.
Like Gavin. No way. I don't believe you. Besides, Chris6662 says that he has line numbers with Express.
Well, he's a cheater. Ooh, you have to hit Show All Settings. Seriously, Microsoft? Okay, go down to the lower left checkbox and hit Show All Settings. They did hide it. Yes, they did manage to hide it deeper.
No kidding.
That's awesome.
All right, so once everybody has line numbers switched on, if you want line numbers on, and you've typed out this very simple little construct for program, go ahead and click your Ready button.
And also, the squigglies in Jason's IDE, just ignore them. That's a plugin that we use.
That you guys will learn about later. Turn off Resharper. Oh God, no, Bazzacad, that's just horrible. Nelson's got the clean IDE. He can do that for you guys. I'm just interested in the words. Segfault, I know you've typed this out by now.
Yeah, seriously, Segfault.
So again, remember, we are using the Ready Check system. So if you are participating, please make sure that you click on the, what is it, the green flag? Yeah, please don't forget to hit Ready.
And you might have to double-click it.
Yeah, and you might have to double-click it, yes.
What subfolder to turn on line numbers, please? It's under the options. It's going to be under Text Editor and then All Languages. To see that option in Express, make sure that you have View All Options checked on the lower left. Sideways mustache.
Okay, Marie, is everything good? Good. All right, we're in perfect shape. So I'm going to go ahead and reset our Ready Check. All right, the next thing that I want you guys to type out is going to be static.
Somebody's asking about curlies.
Okay, wait, what's the question?
How do you type the sideways mustaches?
Well, on a US keyboard, it's going to be right next to the P key on the right. Just simply hold Shift and... Is it JT that asked that?
I think so, yeah.
Nelson, come on. Learn.
Hey, I'm not turning down any questions here.
Learn your members. Very nice, JT. All right, so static void. Now, notice something. This is really important. I hit Tab, so I've indented on line 4. And then static, space, void, space, main. And then an open and a closing parentheses. And once you've done that, hit Enter and give me another open and closing curly brace. And you'll notice how they're indented. So this whole section right here is indented inside of class program. I hear you, Gavin. And yes, Toasted, you can code it all in one line. If you turn in any homework that looks like that, I'm coming over to Australia and smacking you.
Murray, yes, there is if you have Resharper installed.
But first we must go out drinking, Toastage. Good times. Oh, yeah. All right, so I have some stuff that I'd like for you guys to type inside of the open and closing curly brace here. So again, notice how I'm indented. So if you're not indented, make sure you hit the tab. This formatting is going to become very important to us a little bit later on. And yes, Jen, we can restate questions. We need to make sure, Nelson, that we stay on top of that. And
no usings yet.
And Bazakad, yes, yes, yes. Use your incredible knowledge of C# already. Shh, keep it to yourself. All right, so what we're going to do is I want you guys to type out system dot console dot, so these dots are periods, ReadLine. And since you're using an IDE, you're going to find all of this glorious help being given to you as you're typing. And it's great for people like me who has a memory that lasts for maybe 2 or 3 days, and then I forget stuff. So as you're going through, like in this case here where I've typed out system and I hit dot, I can see what's available to me in the class or inside of a system namespace. So now if I use, let's say, console, and you'll notice I didn't even have to type out all of console. So if I do C, I can just hit enter right now because I can see that Intellisense already has console highlighted. Or I can even just hit the dot. Now this is going to show me the members of console, and things like members will be something we'll be getting into a little bit later. But this shows me what's available in console. And what I'm interested in is ReadLine. Notice both the W and the L are both capitalized. And then do an open parentheses. Actually, I'll just finish this off like such. Now the important stuff. Do not forget. What I want you to do is double quotes. And you can type out hello world, just to make those of you happy in BuzzNet. After you type out hello world, make sure you close your double quotes. And the plugin that I'm using is Resharper. Once you guys get past the stage of being noobs, let me tell you what, Resharper is an absolute must. It's an amazing plugin, worth every penny, 100 times over. And so just like how we closed our double quotes off, let's close off our parenthesis and then, or parentheses in this case, and then hit a terminator, which is going to be a semicolon.
Tuzix, the default IntelliSense instead of Visual Studio is going to be different. Do you mean you don't get any IntelliSense, or do you mean it just looks way different? Because I want to make sure that, you know, when Jason said IntelliSense, he meant both what he got and what Visual Studio provides by default.
Oh, he doesn't get anything.
Huh.
Yeah, that's interesting.
Well, here, let me actually type that out in Express without. I wonder if.
Yeah, I'll switch over to you for just a second, Nelson, just in case you stumble on something that causes that.
Let me go ahead and nuke this. What was your program called?
Oh, it's just program.
Let me go ahead and expand this. Okay. So, did you do a public main?
Nope.
So you do system. So you should get a box that looks like that. When you hit dot, you should get a box that looks like this. When you do another dot, you should get a box that looks like this. And then when you open paren, you should get this. So you should get a little white box. Oh, I forgot what this looked like. And then you type in that. And once you close the paren, then it's going to do that. Just a quick note: if inside of Visual Studio, if you type in system dot and you get the IntelliSense window, and then you lose the IntelliSense window and you start typing again, it's not going to come back up without Resharper. To make it come back up, it's always going to be Control Space. So if you get freaked out because IntelliSense isn't coming back, then that's because you have to hit Control Space.
And that's very handy. Unless you're real lazy and you just back all the way back up and re-put the dot in.
Right.
Okay, let's go ahead and switch back over. Okay, at this point, I'm looking for everyone to make sure that they have hit the ready button over in BuzzNet.
I think I lost you.
You lost me?
No, my my webinar window disappeared.
Did it really?
Oh, great. There. Oh, never mind. It maximized in front of my Visual Studio instance, and my brain didn't register the change.
Awesome. All right, we've got one person left that needs to make sure they hit the ready button as soon as they're ready. And Kalani, as if that's how you pronounce it, everything good?
I was clicking your start menu. That's happened with the team viewer.
There. Oh, yeah, for sure. Okay, so, no worries, no worries. So at this point, you've written your first program. If you hit F5, that's going to be a hotkey that we're going to use often. We'll start getting into some of the menu options a little bit later. But what F5 is going to do is compile this very simple application, and it's going to execute it for you. And if you're lucky, you're going to see a window pop up real fast and then go away. Because the execution of this program is very straightforward, it's very simple, and there is nothing at all that is going to cause it to halt. So from start to finish, it's just going to start inside of main, which we'll be talking about more in a few minutes. We're going to execute WriteLine, which is going to actually write out hello world to the console. Then we're at the end of main, and so we're at the end of the program. That's it. So
yeah, a thing to keep in mind when programming is the computer is going to always do exactly what you tell it to and nothing more.
Even though there are nights when Nelson swears, that is honestly not the case.
Yeah. Visual Studio just hates me.
Okay, so I'm going to go ahead and reset the ready check. And if you just put your cursor at the end after the terminator and hit enter, you should swing down below your line number 6, if that happens to be where your system console line is. So let's go ahead and tell the program to halt execution for a moment until the user hits a key on the keyboard. So to do this, again, we're going to head back over into System, back into Console, and then this time, instead of writing something out to the console, we're going to read. Now we have a read key and a read line that we can take advantage of. So let's go ahead and just do read key. And then after read key, go ahead and put an open and closing parentheses, and then terminate. So again, it's going to be system.console.readline.
ReadKey.
Or ReadKey, excuse me. I was talking out loud while looking over at the ready checkbox. So we're over 50% checked off. There we go. Awesome, guys. Fantastic. And if you hit F5 now, again, it's going to build out your application into an executable, and it's going to launch it. And so now we're actually just hanging here with the console, and you can see hello world. So there's still a few of you guys left that have not clicked on the you're ready. So make sure you do that once you are. And so now at this point, your application, while running, again, F5 to run it. For those, Kevin, if I recall, you may not have BuzzNet running on your machine. This is only for those of you that are running BuzzNet and following. All right, and we've got everybody that's checked. Outstanding. So again, hit F5. Your application is going to compile. It's going to launch. You're going to see hello world. And we're just going to be sitting there waiting for you to hit a key. So we're reading for any key on the console. So if you hit a key, your application is going to terminate because we're now done. We read a key in, and after reading this key in, we're then right here at the end of main, and that's it. So we exit out. And Kevin, you asked where BuzzNet is. You can download BuzzNet in the Member Sponsor Lounge. Currently, it is in the registration thread for the C# 101 class at the very top. So on the very first post. Easiest program in the world, eh? No problem, Kevin, no problem. You're welcome. So we can go in here, and just to show you how execution is taking place one line at a time, let's go after System Console ReadLine. So again, put your cursor at the end, hit Enter, and let's do another write line. So again, I'm just going to do system.console.writeLine. And then inside of the parentheses, I'm going to tell it, I don't know, Gavin is your TA. Now, if I run the program right now, somebody over in BuzzNet quickly let me know what's going to happen. Man, yeah, it's nice to... Wolfrey got 2 achievements for the debugging class. Nice. Okay, so Bazakat says we're going to see hello world, which is correct. And it's going to sit there and it's going to wait. Good job, Mike. And we've got other good answers coming in. Absolutely. So basically, when we execute the program right now, again, we start inside of main. So the first line that is going to execute is going to be hello world getting written out to the console. The next line that executes is going to be the console's class ReadKey method, which is going to halt execution, and it is going to wait for the user to hit a key. Once the key hits by a user, we're going to execute the next line, which will write Gavin is your TA out to the console, but there's nothing to hold the application up for us to see that. So it's going to be a really quick flash, and then we're at the end of main, and when we get to the end of main, that's the end of the program. So go ahead and hit F5. And just like many of you said over in the BuzzNet chat, the console window comes up, looking at Hello World, and as soon as I hit a key, boom. Now I saw a quick flash of, all I was able to catch was actually TA, though the entire line was written out.
Just to throw some terminology in there, lines 6 through 8 are called statements. So whenever you hear the word statement, that's basically one kind of unit of what your code is capable of doing. This is one type of statement that you see here. There's many other types, and every statement is generally going to be terminated with a semicolon. And that's not always true for all types of statements, but in this case it is. So those are 3 statements. They don't actually need to be on the same or on different lines. You could have them on the same line if you wanted you to, because C# does not care about your formatting or white space. The semicolon is what instructs the C# compiler that your statement is finished and that it should treat everything before that semicolon as a piece of that statement to execute. So in this case, we have 3 terminators and we have 3 statements.
And we'll come back to statements again in just a minute as Nelson jumped ahead into C# syntax fundamentals.
Well, I'm looking at I don't have the right outline then.
Yeah, you do.
I'm looking at the Google Doc.
Look in 3D Buzz. Yes, you can definitely comment your own code with notes, which we will be getting to comments coming up here very, very, very shortly. Though, as a quick, you can just do 2 slashes and start, and that's a single line comment.
Completely ignored by the compiler and by me.
So if we wanted to halt execution after line 8, after this line right here, what would we do? The exact same thing that we did to halt execution back here at line 7. We need to basically read a key. Except this time, let's do system.console. Instead of ReadKey, let's do ReadLine. So what ReadLine is going to do, instead of reading just a single key, it's going to read, it's going to basically wait until you hit the enter key. And it's going to read everything that you've typed in on that line. But since we're not doing anything with what's been typed in, as soon as it detects the enter key, then we will progress to the end of main. And at the end of main, that's it. Yeah, it does sound like you have some sort of jet fighters over there.
Yeah, we live next to a Navy base.
There you go. So once you have this read line in, just go ahead and hit F5 again. And we see hello world. Now if you hit any key, nothing's going to happen except for, which I'll demonstrate this again by rerunning it. So if I start typing, it's just going to let me type until I hit enter. Read line, read key, or write line, read line, and read key. These guys are going to become important by the end of the class. And we're going to be using them in assignments starting today. So again, a very, very simple C# program.
Your gav line is slightly indented. I mean, do you mean your output of oh, that's going to be because of the read key.
Right, and let's not worry about that at the moment.
Yeah, I just want to make sure that it was innocuous, which it is.
Yep.
It's just the read key.
Now, inside of .NET, there's a bunch of classes available to us that we can make use of so that we don't have to continuously reinvent the wheel. And system happens to be one of the collection of classes available to us. And inside of system, which is a namespace, we're using the class console. You can see right here that we've actually defined our own class. So class program. We could have called this anything that we wanted to. It could have been, my program. And if I hit F5, you'll see everything still functions just fine. And I'll hit enter a couple of times to go ahead and complete execution. But what's important inside this class I've defined is what is known as the entry point for the application. And the entry point is main. Now there's a bunch of different ways that we can set main up. So we can have return types and we can take arguments in and things like that, but we'll work our way up to stuff like that. I want it to keep things as simple as possible. But since using is something that you guys all see the moment you create a new application, as a matter of fact, when all of you followed along with Nelson earlier and you created the new console application, you all had usings up at the top. So what I'm going to do is I'm going to put using up here, and I'm going to say system. Now go ahead and do that. As a matter of fact, I'll go ahead and reactivate the ready check. So after
don't worry about the gray.
So after you've put using system in, what I want you to do is come down here and remove the system before each of the consoles. So as you can see, we did not have to have this line up here saying that we want to use system, but without having that using statement there, we had to explicitly tell the compiler where console is located at. Because right now, if I use 2 forward slashes, that is a single line comment. So this is now being ignored by the compiler and by Nelson. So it's like this doesn't exist. That's how you put your own notes in there. But you'll notice that all of my consoles, they're going to turn red. And if you try to execute your application, it says that there are build errors. So if I tell it, no, I don't want to run any past build of it, you're going to see the name console does not exist in the current context. It doesn't know what console is. Console is a static class made available to us inside of the namespace system. So there's actually a bunch of different things that are available to us inside of system. But console is the thing that we're using. And since we're using it multiple times, instead of having to type out system dot before every single time we want to use a class from inside it, at the top, we can simply say using system.
Think about it like files and folders, basically, where system is a collection of a bunch of individual pieces of code that you can access inside of your program, but you need to have access to, that's what the namespace is. I know some people were asking, what is system then? And Jason said multiple times that's a collection of functionality you could use. The term for it is a namespace, which I'm sure you're about to
Correct.
say.
Actually, I did say namespace a minute ago.
Okay. I just want to make sure I wasn't jumping ahead again.
Nope.
But just the analogy that I like is folders and files. Think of console as a file and system like a folder, and console lives inside of system. System is similar to include. Using statements are sort of kind of similar to include. Include in C++, and I don't know how many other C or C++ developers there are right now. But what include does is it grabs a bunch of code from another file and stuffs it into your file. C# doesn't work that same way. C# is all compiled in multiple passes, so you don't have to forward declare anything, meaning you do not have to use the include, any sort of thing that does what include does in order to make C# work. But you do have to specify what external code you want to use in the form of either a using statement at the top or repeatedly qualifying the path to the piece of code that you want to access elsewhere.
And again, qualifying, what he's talking about is doing that.
Yeah, that's what's called a fully qualified class. System.console is fully qualified.
And as you can see, it just adds a lot of extra verbiage into your code. It makes it a little bit uglier. It's just a lot cleaner if this, well, did not exist. And we can get away with that by saying we're going to be using the system namespace. So it's kind of like it takes everything that's inside the system namespace and it makes it available to us.
And namespaces are really important. If you're curious as to why this even exists, it's mainly due to naming conflicts. You'll run into that quite a bit where if you try to name two things the same thing, you will, well, not be able to because the C# compiler can't differentiate between them. So you use namespaces in order to reduce those conflicts.
Okay, there's still a handful of you guys out there that have not yet finished. So make sure you click the ready. Good deal. There we go.
What about naming project after, say, system? Will you need to do a full on any code attached? Are you asking if you write a class named console and put it in your own namespace called system, would you have to qualify it every time that you access the real console? Yeah, it's not something you'll want to do, but I think that was the question. And that to answer that question, if you were to name a class,
go ahead and restate what the question was.
Well, I believe the question was if you were to name a project called system, would you have to do a full, I'm assuming a full qualified name on every time that you access system.console? And the answer to that question would be yes, but you should try not to do that because that would be a pain. There's nothing stopping you from making something called console or system in your code, but you will run into a lot of difficulties with that.
Yeah, absolutely. All right, so we're almost there. So again, make sure to hit the you're ready once you're ready. All right. So at this point, what I'm going to do is I'm going to go ahead and remove lines 9 and 10. And I'm just simply hitting the home key to jump back to the very beginning, holding shift and hitting the down arrow twice. And you can get rid of it however you want, but that's just how I do it, and hit the delete key. So we're back to very, very simple program. Your first program ever, should be, for most of you guys. And with this written, that's going to allow us to move into a quick discussion on compiling and running applications. And one of the things that we had talked about when putting together the syllabus is having a quick discussion over native versus managed versus dynamic. So Nelson, you want to go ahead and talk about that?
Yeah, so there are many ways to classify programming languages, and one of the main ways to classify a programming language is if it's native, managed, or dynamic. Those three words have to do with how the code that you write in that language turns into something that runs. So whether something is native, managed, or dynamic, those are three sort of categories of how you can type in source code and have you able to produce a result. Dynamic, I'm bet if anybody here has had some experience with a programming language, it would probably be a dynamic programming language. And those languages are like PHP, Ruby, Python, JavaScript. Those are all dynamic languages. And dynamic languages are generally going to never be pre-compiled. You don't have to run the code in a dynamic language through a compiler in order to run the result. Instead, what you do is dynamic, I just got a question, is dynamic a synonym for interpreted? Generally, yes. There's a bunch of, like I said, languages that fall under native, managed, or dynamic often exhibit a particular set of characteristics. That's not necessarily always true, and I don't like saying things that aren't necessarily always true, but you can think of it that way. The majority of the dynamic languages that I just specified are indeed interpreted. So for PHP, that's a very popular language, and a lot of beginners play with it and use it. What you need to do, if you're familiar with that, what you need to do is you need to type code into a PHP file, and then you stick it on a server somewhere, and you can run that web application. Now, what's happening is the server itself is interpreting your source code line by line. So that's one of the ways that you can get from a result to a running program. But what you do need is you need an external piece of software, generally called an interpreter, that takes your source code when you run it and turns it into a running application without having to go into an intermediate step. On the opposite side of the spectrum, we have native languages. An example would be C or C++. Those are both native. And when I say native, I mean that if you take the source code of C or C++ as a language, you type it out into a program like Visual Studio, you have to run it through a program called a compiler. But the result is an executable that can inherently be run on the platform you compile it for, which is good and bad. It's good because it's significant. It's generally faster and requires no additional overhead or additional software components to be required in order to use that code, because it's just in a self-contained container, that was redundant, that is understood by the platform that you are compiling against. So when you're working with the native language, if you wanted something to work on Windows and Mac, you would have to create two executables, because one executable would only be understood by Windows and the other one would only be understood by Mac. Then again, there are performance benefits of using native languages. They're not as significant as they used to be. That's kind of a myth that irritates me. But yeah, so they go into, you start off just like what Jason is writing. You have a source file that you write in the language.
To let you know, Nelson, since this is a complete beginner class, I'm going to leave out the concept of objects and linking, okay?
Oh, yeah, I wasn't going to.
Okay, I just didn't want you to start mentioning that, and we're going to keep this easy.
Yeah, but it's very important to And the goal here is to get the sort of magic of what's happening removed to as much as we can at this stage, because something that a lot of people do when they start writing code is they start writing code into an IDE, they hit a button and it magically produces a result. But understanding that that process is not magic and actually pretty straightforward, it will make it seem a lot less scary. So like Jason wrote, CPP or C++ will go into a C++ compiler and give you an executable that can be run without any additional components installed on the program or on your computer.
Of course, the machine language instruction set is going to be obviously, based off of the compiler and what architecture you have targeted. Do you want to talk about that for just a second, Nelson? Because that is kind of important.
Yeah, every computer has a CPU in it, and that CPU is going to be classified as one of the variety of different architectures that are available. And we're all currently, if you're following along, you're running on an x86-64 architecture, which is the specific type of CPU. And the benefit and drawback of a native language is the compiler actually prints out code, executable code that can only be understood by the target platform, period. Then it does another step. It will only generate an executable that is understood by the platform that you are running on, the operating system that you're running on. Even if my Mac and my PC both have an x86-64 architecture, the packaging format that the compiler will use will be different depending on each platform. So that is an example of why cross-operating system compilation with a native language is particularly difficult. Especially, and then you have like ARM. So if you ever wondered why you couldn't use or run a program that you were on a Windows on your smartphone, which is most likely an ARM architecture, that's the reason why. The executable is simply not understood by either the operating system or the platform itself.
So obviously C# is a managed language. And so a little bit different here, as you can see that from native down here in the managed example, we're going to have our CS file, and we're going to use a managed language compiler. So, of course, in this case, we're using the C# compiler. And so what's getting compiled out is not an executable that will run natively on that particular piece of hardware, on the architecture, CPU architecture. Instead, we still see an executable, or of course a DLL. But in this case, we're just going to stick with an executable. But this executable is known as an assembly.
Right. It looks like a managed executable or a native executable, but it's not. Windows just knows how to work with them differently.
Inside, it contains intermediate language, or what's often spoke of as the common intermediate language, the CIL. And it also contains metadata.
And like what Jason already said, this information that is in that box has no meaning whatsoever to a CPU.
And that's really one of the very cool things about, .NET and the way that the whole architecture works, which is, go ahead, Nelson.
Well, someone just asked, how does the .NET framework come into this? What we're explaining right now, the .NET framework is an all-encompassing term for a collection of components. What we're actually explaining right now is how the .NET framework goes from C# code to an executing program. So this is the whole process of the .NET framework. That's how it relates.
And so let's see. Interesting little diagram to draw out here for those of you that are really curious. Let me see how much space I have. Whoa, absolutely none. Well, still none. Okay, fine. So here we are. One second. Our computer.
That's a terrible box.
You know you love it. Hush up. Which is named Buzz 3 in this house. And here with my most. I know I can hold shift down before anybody even comes over there and says anything. So here's my operating system that's running. Now I double click on an executable, a native executable app. Basically, the operating system knows how to go about setting up what's required for this guy to come in and start running. This is basically what's provided as a process address space, and inside the process address space, our program, notepad or whatever it may be, .exe begins executing. We get a main execution thread that gets set up, and any other DLLs that need to get linked in will be linked in, and so that they're available. Basically, everything gets set up, and here we are running in our own process address space. When we double click, and so that's like double clicking on this guy right here. So when we double click on our .NET application that we wrote in C# and compiled out, what happens is it's still going to start out exactly the same. The operating system is going to take a look at the executable, and inside the executable, there's a thing called the PE header. I got to be real careful here and how far we step into this, but basically there is some very simple instructions inside that basically they get compiled out with your executable that will bootstrap the CLR into starting. Now the CLR is the Common Language Runtime from .NET. Now remember, when I drew out the executable earlier, this guy right here, it doesn't contain actual machine language inside this file. Instead, it contains intermediate language. So it's kind of halfway to the machine language step. But this is the really cool thing, because they wanted .NET to allow for compiling and execution to be able to take place on different architectures. So we have this IL, but we need somebody who is going to be able to take that IL and further compile it to the native machine language for the architecture in which it is running on. So we've double-clicked this application right here. Again, same thing is going to take place. The process address space is set up. The image of the executable gets loaded in. But inside the PE header, there is some information that is going to end up bootstrapping the CLR, the Common Language Runtime. And we're going to be talking more and more about the CLR as we progress further and further into these classes. But the CLR is really the heart of executing any .NET managed application. So once the CLR gets going, of course, the IL and the metadata, all of that got copied in at first. We got an image of the executable copied into memory. So again, this is IL, and I'll just put MD, metadata. So once the CLR gets running, it's going to set up things like the heap, which is something else we're going to be taking a very close look at. And it's going to get the main execution thread running, and any other threads that are needed, because, again, we can have our own thread pool as well inside of this process address space that's taking place here. So once this gets done, the CLR then knows where inside our IL code execution needs to begin, basically where the entry point for the application is. And you guys have already seen it back over here in main. So main was our entry point into this application. So what's going to happen is it's going to take this method, because main is a method, and it's going to compile this code into the proper machine language code for the architecture in which we are running on. So as Nelson said, x86, 64, so let's just say that what happens is the CLR takes this and compiles it, I'll just put x86, for the appropriate architecture. And then execution begins. And that compiled method is then basically cached. So while we may have, I'm sure we will, hundreds or thousands of other methods, those methods have not yet been compiled. The compilation process is known as just-in-time compiling, or JIT compiling, which means that as soon as we have a method call, if that method call has not been, and I know to a lot of you that's complete Greek, but it will make a whole lot more sense a little bit later on. But when a method call is called, if it has not yet been compiled, it will, well, just in time compile it and then allow for execution. But the next time that method gets called, it's cached. So it does not have to go through the process of compiling it again. So basically, as you run your program will get faster and faster and faster. And if speed is an issue, there is a way to compile ahead of time in such a way that JIT compiling at runtime doesn't happen. But that's beyond the scope of the discussion right now. So Nelson,
and also gets rid of some of the benefits that you get from this.
Absolutely. So Nelson, would you like to add to anything here?
No, I mean, that's pretty much the process that managed code takes. Some people asked, was this like Java? And the answer is yes. Java is another managed language where your Java compiler turns your Java class files into Java bytecode, which is synonymous with IL. And then at runtime, the JVM just-in-time compiles the Java bytecode into the appropriate language. Now, the implications of this are actually very, very interesting because the implications that your CS files are compiled into IL is that you can run that same IL file or that same executable file that contains managed code between platforms. Microsoft doesn't support any platforms other than Windows Phone and Xbox for a CLR. They have a stripped-down version of the CLR for Mac for Silverlight. That's about it. But there is another project called Mono, which is a project that does have a CLR available for all the major platforms. So you can take that executable and run it on any system. Also, I remember somebody asked a question about C# and Android. That's another implication is some people have taken Mono and made an implementation for Android for that, which makes it so you can run the same executable on Windows as you can on Android, obviously with some modifications because you don't have the same Windows and stuff, but you know what I mean.
I mean, the whole idea of .NET and its specifications does make for a wonderful world. I mean, it is nice being able to develop code in C#
Yes.
that's going to run, in Unity and on an iPhone at that. And that's
well, exactly.
quite
and
handy.
C# isn't the only language that compiles down to IL either.
No, there's lots of them.
So that IL, that intermediate step, basically provides a common way for language interoperability, meaning you can invoke code or you can use code from any language that compiles into IL from any language that compiles into IL. And the big ones right now are going to be C#, VB.NET, and F#. There's quite a few other ones, such as Boo, which also compile down to IL. So it provides this really great compatibility mechanism that just doesn't exist in native code. Native code, you're restricted to, I'm not even going to go through the process of invoking from one native process to another, but it's convoluted.
Yeah, without a doubt. So the big thing to remember from this discussion, just in case it seemed technical in any way, I tried to keep it as simple as possible, is right now you guys are working in a managed language, C#, and you're going to be creating these CS files. So these are your code files. And then we're simply going to compile those. And when they get compiled out, we're basically turning them into assemblies. And inside the assembly, we have IL instructions and we have metadata. And then when you execute, if what you compiled out was not a DLL but an actual executable application, like you guys have created with the quick hello world, then this executable, its headers are like for the most part, are like a normal executable. So the operating system is going to do its standard stuff to run this guy. But in the process of getting it mapped into its process space and all, there's some instructions inside of it that will fire up the CLR. And what's really cool is it's going to take a look at the metadata, and it's going to determine which CLR version needs to be run, because there are different versions of the CLR. So you can have side-by-side execution with different processes running CLRs of different versions, which is pretty cool. But that gets into a bit more of an advanced topic. But it's that simple. So we write source codes, source code, excuse me. We compile it out. We're left with our assemblies. When we execute our assembly, it gets loaded in as a process. Everything gets set up in that process, and the CLR is bootstrapped in, and it begins running in that process, and it takes over from that point and begins executing your code.
A question just came in. Isn't the JIT compilation a bottleneck for real-time applications, at least every time a method is compiled? Shouldn't there be an option to batch precompile all the methods before the first run? And yes, there is a way to do that. It's called NGen, but it's not something, like Jason said, that we're going to be going over.
Yeah, I did mention that earlier. Go ahead.
Yeah, you already said that. But however, that's not a performance bottleneck. A performance bottleneck is something that will consistently cause an issue during a real-time application, so something in an update loop or something like that. The JIT compilation is very fast, and it is only executed once per method. So it's not a very big issue at all, especially after startup. But even at startup, you will not notice a big difference. I think I did some performance testing a while ago, and it was like a few milliseconds, or less than a few milliseconds, for a compilation of a fairly large method. And then after that, it was repeatedly the same performance as you would get from a native programming language.
And with the execution engine being optimized for each architecture, it's awesome because basically they have squeezed every ounce of performance out of the CLR, for a given architecture, which is really nice because you're going to get, very streamlined performance out of your managed applications.
Yep, and Segfall just pointed out something cool. Also, your code could be years old, but because the .NET platform has been optimized, you get those optimizations for free. Yes, like for example, they're doing a multi-threaded garbage collection in .NET 4.5, which you're going to basically get for free for all of your .NET applications.
And Marie's having a flashbacks of College Computers 101. Come on, this is important stuff, though, to let you know what's going on under the hood. And, we're hitting that F5 button, which actually does a little bit more than I'm letting on at the moment, but it's kind of what's taking place. Nelson, you were about to say something? Go ahead.
Yeah, I was kind of thinking about throwing a text file up and CSCing it.
Throwing up a what?
A text file and compiling from the command line, if you think that would be...
Yeah, here, I'll hand it back over to you. I know you were just kidding, Maria. It's great.
But the biggest thing is, we already showed what a basic C# program looks like, but too many people are just kind of afraid of the whole process, and just not being afraid of that process will go miles.
Absolutely.
Okay, so I'm going to go ahead and open up a Explorer window. I'm going to go into my Documents folder, and I'm going to, actually, what am I doing? I'm going to open up Notepad. Okay, so, actually, you know what? I have a Ready Check button. All right, so go ahead and get a Notepad window open, and then copy and paste your code. I'm going to go ahead and add the ReadKey.
Sorry, well, I can't repeat what Wolfrey said, but that's pretty funny.
Yeah. Okay, copy and paste your code into a blank Notepad file. So just a text file, or Notepad++, whichever one you prefer.
Oh, come on, man up and do it in regular default Notepad.
All right, so then go ahead and hit Control-S. Save it somewhere. I'm going to stick it in my Documents folder for now, and call it Program.cs. So make sure you have the .cs extension, and go ahead and hit Save. Once you have this saved and you can see it inside of your Windows Explorer window, go ahead and check off the Ready button.
Yeah, I do agree with Gavin. Let's try to keep the language PG-13 over in the, or PG over in BuzzNet.
Oh, PG-13 these days.
Yeah, I know. I revised what I said.
Save it as Program.cs wherever you want to save it to. And hopefully this will also put in focus what exactly, why you should be using Visual Studio instead of not using Visual Studio or any other IDE. All right, we still got a few
Just
people.
a few. Thank you for the ready over in the chat. And we're close. And for those of you guys needing a break, we're going to take one in just a few minutes once Nelson gets done with this little demonstration.
Can't we just use binary? I mean, if you wanted to write an entire PE in a hex editor, then you are more than welcome to. I've been meaning to do that one day, just so I can say I did.
Mm-hmm.
All right, so you guys...
Almost. Okay, everybody's ready?
All right, sweet. Okay, what I'm going to do now is I'm going to go to Start, and I'm going to type in CMD into my search, open up a command window. So again, if you're running Windows 7 or Windows Vista, just hit Start, type in the letters CMD, and hit Enter. Alternatively, if you are not on Windows 7, which you should be, I believe it's under on XP, it's under like Accessories Command Prompt or something like that. Or you can hit Windows key and then R. If I can find my Windows key. There we go. And type in CMD into the Run window. Okay, so get this open. Go ahead and navigate to where your Program.cs is. In my case, it's under my Documents folder. So you can see it right there. So make sure that you're navigated to that folder. There's a blank one between the two blank ones near the big blank one if you're Nelson. What?
I don't know.
I don't know either. Okay, I'm going to type out a command. This command will be slightly different if you are running on a different platform. I'm running on x64. It's going to be slightly different if you're running 32-bit. But type this in: C:/Windows Microsoft.net / you're going to want to do framework or framework 64, depending on what platform you're on. I'm going to do framework 64. Then type in type in this version 4.0. Blah blah blah.
That's if they're
csc.exe. So get that all typed out. So some people might not be able... Hold on, I'm going to do the ready check again. I love that button.
Yeah, good luck, Nelson, because this could get tricky for some people that are not very comfortable navigating through the shell and those that may not have that version of .NET installed.
Yeah, this version hopefully will come with Visual C# Express, though. Hopefully. The Framework 64 thing is the biggest one. If you're running 32-bit, you will want to do Framework. Also, I guess I can also just show you guys that folder in general. It's under Windows, Microsoft.NET, Framework 64. Then you can see all the versions of .NET I have installed. Then underneath this, you'll get the .NET Framework under here, which includes a lot of awesome stuff, including a C# compiler and an F# compiler and a VB.NET compiler. And hey, there's NGen, which we were talking about earlier. So this is the .NET Framework, essentially, all the tools that you need in order to work with .NET Framework. The C# compiler, csc.exe, is available on every single .NET Framework install.
And if this does get a bit techy and you want to just watch what Nelson's doing, that's completely fine. Just go ahead and check your participating button so that it pulls you out, and then you can jump back in with participating once we start the next round of things.
Somebody broke the ready button, apparently.
Really?
Yeah. Apparently they're getting major lag. That might just be a... Ooh.
Ooh, what?
Oh, no, never mind. The server is getting hit. Can't ready up. All right, well... Yeah, I'm watching the server. There hasn't been a single exception for BuzzNet whatsoever. Ooh, there is definitely lag. Huh. That's good to know. Maybe it would be good to, once we take the break, hopefully it'll clear up. But if I see most of you already have this typed out. Yeah, DDoS attack, I'm not sure. Okay, well, we'll look at it later. Anyway, we got most everybody ready. And I want to wait a little bit to see if the server calms down. Maybe it's just we're getting some traffic right now. Might be Google or something. Okay, so now that most everybody's ready, if you're not ready, just don't worry. Just watch what's going to happen here. Go ahead and, now you have CSC selected, go ahead and type in Program.cs and hit enter. And what happened was just really awesome. So check this out. We get some messages, Microsoft Visual C# compiler version 4, blah, 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 copyright, and then nothing. What actually happened is right here, we now have a program.exe inside the same folder that we can just run. And the entire process that Jason's been describing is happening with this file. This is what Visual Studio does behind the scenes. It invokes csc.exe and passes in all of your program files, and then it runs it. It also, for example, if I were to edit this and put in a syntax error, the csc.exe will also show you syntax errors right here. This is how Visual Studio gets that information out, because it parses out the output. Good question. Visual Studio does make an executable for you. Sorry about that. So do you have to do that to make an exe, or will Visual Studio make an exe? And the answer is yes, Visual Studio will. Right now, Visual Studio will, if you're using Express Edition, Visual Studio will not be producing the executable in somewhere you can access, which we'll talk about at some point maybe. But because the way Express works, it doesn't actually save your project file out to a disk until you hit Control-Shift-S. Ooh, lag gone? Yep, lag's gone. Awesome. So yeah, so Visual Studio does produce an executable file, and it produces it in a folder that's going to be a subdirectory underneath your project file, wherever it exists physically on your hard drive. But this is all Visual Studio. At the end of the day, this is all Visual Studio does. Just runs that program.
Okay, so at this point, we're about an hour and 24 minutes of actual recording time into class. Let's go ahead and take a break for about 8 to 10 minutes. So if you need to go get coffee, use the bathroom, or whatever, now is a good time to do it. And then we will resume. Nelson, can you put any type of text file up that just says currently on break? Fantastic. All right, so let's go ahead and take a quick break, guys, and then we will resume once we get back. So like I said, 8 to 10 minutes, and we'll see you guys back in just a moment. I'm going to go ahead and pause recording as well, just for the sake of those watching the video later. So pausing. All right, and we are resuming, so hopefully everybody is back to their seats by now. So continuing on, at this point, Nelson, was there anything else that you wanted to talk about in regards to showing the compiler and compiling it out in the shell?
Not really. I just wanted to demonstrate that that's a process that Visual Studio will go through when compiling your application. There was a good question that I answered off camera where somebody asked why the build from Visual Studio is slightly larger than that of the command line. And that's because Visual Studio is going to be sending in flags to the C# compiler when you're compiling in debug mode. That adds a lot of weight to the compiled executable.
Right.
But other than that, yeah, and hopefully everybody has a relatively good understanding of the process that is going on when turning text into a running program.
So Nelson, I'm going to go ahead and pull the screen sharing back over to my screen. And as we get ramped back up here, let me go ahead and remind everyone, especially for those that are new to dealing with us over here at 3D Buzz, how we are when it comes to time. Since I know that we're recording this, and I know that it will be supplied to you as a video that you can watch at any time after it gets uploaded, I am not stressing with the clock. Please make note of that. If I know when you're attending a real live class that if the class was set between, X and Y, that the class needs to stay between X and Y because people have other things to do afterwards. Once we reach a point in which you feel that you need to go to bed or go to work or continue or whatever, please feel free to do so. It's not going to hurt anyone's feelings because, again, the video will be made available to you to finish watching at a later date. It's most important to me to get the content out that I want you guys to have. So I'm not like one of those instructors that's watching a clock and as soon as it, ticks the end of class, it's like, yay, we're over and we'll just pick that up in next week's class, which means we'll end up with longer classes. That's almost always common when we teach stuff, including our private lessons, which are only supposed to be between 1 and 2 hours, and they seem to always be ending after about 3 to 4 hours religiously. So I wanted to throw that out there just in case there's any of you that are watching the clock going, I need to get going. It's okay. But I want to continue with the lesson and getting everything out that I wanted to share with you guys today. So with that, let us see. What can we come in here and do next? I don't know. What do you want to do, Nelson?
Well, we can definitely go over...
I'll be quiet. You're talking. I'm just giving you a hard time.
Hey, you asked me to talk.
I'm just giving you a hard time. Let's take our canvas size and let's make the height of this larger. Hey, that's going to give... Do what?
As long as your computer can handle it.
Nice. And, oh, did I not? Hang on, Control Z. 1 second. There. And 1 second. Just because I get really picky about having space to, draw on.
On your awesome whiteboard?
What? You have a problem with my whiteboard, Nelson?
It's lacking the white.
What? Oh, be quiet.
You know you can use Control Backspace, right?
Yes, I do.
Okay.
So let's see. Give me a second, guys. For those of you that like to take notes, I was actually talking with Suzanne and Meta during the break a little bit, and we were talking about those that like to take notes. When I'm drawing out on the screen, this is a really good time to take notes if you are one of those that enjoy doing so. So what I'm going to do right now is go ahead and get my brush activated again. And now that I've given myself the room, let me actually jump down a little bit. I don't want to have to dig through a ton of different layers at the moment, which, by the way, is why I'm staying right here. So I'm going to go ahead and And let's go ahead and make this capitalized.
Wow.
What?
Class pro.
Oh, shut up.
Pro.
Do you want to have to start writing?
You don't want me to write.
Then be pleased. I already know how horrible my writing is.
I don't think you've ever even seen my writing. I hope you never do.
No, I don't think so. And I'm going to go ahead, now that everybody understands what using is, I'm going to do a using system up here to bring the namespace in. And then let's just do, this will make a lot of sense in just a second. I need to add what?
They need to add Intellisense into Photoshop.
Let's just say hello, just to save on typing or writing. Okay, so there's the little program that we all wrote just a little bit earlier. And what I want to do now is move into the C# syntax fundamentals. And the idea that I had when we put the syllabus together was to use the very basic program that everyone wrote in order to review this, to review the different things we're going to be talking about in regards to C# syntax. So first thing that I want to talk about is main. Very, very simple. And let me go ahead and draw a line in there. See, I finally draw a straight one, and it points out how crooked everything is. So as we mentioned earlier when we were writing the program and executing it, and then I also mentioned it once we moved over and started talking about compiling your program and executing it with the CLR, we have to have an entry point. Basically, there's got to be a place in which execution can begin. And at that point, execution is very straightforward, literally. I mean, it does one line, then it does the next line. Now, of course, we're going to end up jumping all over the place based on what your code is instructing the CPU to do. But the key thing to understand is still it's all going to be a linear execution. And main is going to be our entry point. Now, this main right here, this is a method. And a method is a block of code that can take parameters in, and it can also return a value as well. Right now, we're not taking any parameters in, so you notice I have an open and a closing parenthesis there, indicating there's nothing coming in, and right now what I'm returning back out is void, so that's nothing. So nothing is being returned at all. I don't expect for you to understand what I'm saying, but I want to mention that because later on that's going to become important, and I've at least planted the seed. Now, in defining a method, after we set up the method header, which we can just look at as being this line right here, the most important thing to note is that we have this open and closing curly brace. This sets up our block of code that is going to belong to main. So once a method is called upon to execute the code inside, execution will begin at the very first line inside of that method. Now, since main is a very important method, it is our entry point into our application when we execute our program. Man, that is horrible right there. Then that means that the very first line of code inside here is the line of code that is going to execute when we run our program. Now, in this case, we have called upon a type called console that is available to us inside of system. Now, types come in all sorts of different flavors, as we have enums, we have classes, we have delegates, we have custom types, etc., etc. But console is one of thousands of classes that are available to us with .NET. Okay, in the BCL. You want to talk about that for a second, Nelson?
As far as what the BCL is, the BCL stands for the Base Class Library. Base Class Library, BCL, is a collection of code that takes the form of what Jason just described as a type. a collection of code that is usable from any .NET language. It's part of the .NET framework. I'm not entirely sure if it's part of the .NET framework specification, but it.
Go ahead.
But the implementations of the .NET framework will always have these particular classes available to you for use for doing standard operations. If you're familiar with C and C++, you'll know that there's a million ways to do certain things like opening a file or writing out to the console or whatever. In C#, that's all standardized, and it's all standardized under the BCL. If the BCL can do something, that's what you should use to do whatever you want to do. In this case, it's writing out to the console, doing basic console input and output, which is just one of the many facets that the BCL provides us. It provides us functionality for opening and closing files, for dealing with network streams, for parsing XML, for talking to databases, for even things that don't have to do with input and output, such as performing computations on data. There's just a bunch of functionality that's provided by the BCL. All of that functionality is going to come from the class libraries that your program by default will always have a reference to. Well, yeah, I said by default. You can always, not make that true, but you shouldn't. And that's going to be your MS Core Lib, your System DLL, and your System.Core DLL. Those are the main libraries that you're going to be using quite often. So console.WriteLine is just it's not a part, I just want to make this distinction clear. Console.WriteLine is not a part of the C# programming language. It's part of the .NET framework. It is simply included by default into your C# program for use by you to do basic input and output.
Very good. Not bad, Nelson. So main, as we just said, is a method. And it's also our entry point into, there's a T in there, our app. So where execution actually begins. So keep that in mind. The next thing that I want us to talk about is going to be keywords. Just like with any language, there are predefined keywords, even with the English language. There's not that many of them in all, but just to give you some of the examples, I mean, you've already seen some here. Class is a keyword. Using is a keyword. Static is a keyword. Void is a keyword. So again, there's a handful of them. We're going to get into things like if and else and for loops. These are all keywords, words that define, that are used in the C# language. Nelson, do you have anything you want to add to that?
Yeah, actually, there's two things I want to mention before, though, really quickly. First, somebody asked, WindyButt asked, can any other method be our entry point? The answer to that question is yes. You can instruct the C# compiler to use any method you wish as your entry point, but you really should just use main.
Right.
That's the standard. The second thing I want to say is something that pretty much everybody has probably already intuitively gathered, but I kind of want to define it right now that we're going over syntax. And that is, a programming language is literally just a specified language, a normalized formal language that you have to follow the rules of so that another program can take your language and do something with it. So it's not something magical. In itself, a programming language is nothing. It's a standardized thing. So we'll be talking a lot about the C# specification. The C# specification is what defines the formal language of the C# language, which was very redundant. So as a keyword, like I said, the BCL is not part of the C# specification itself. Keywords are. Keywords are define how you take text inside of a C# program source code, or a C# code file, sorry, and turn it into a program. And keywords have special meaning and cannot be used for particular things because, again, they are latched onto by the compiler to take hints as to what you're intending to do.
Okay, the next thing, which has already been covered a little earlier, is going to be statements. So you want to remind them quickly, Nelson, what a statement is? I mean, we have some examples of statements up here.
Yeah. A statement in the C# specification, there's a variety of, I guess you could say, contexts of where certain things go. And inside of a method, inside of main in this case, what goes inside of a method is always going to be a collection of a group of statements. And a statement is always going to define to the C# compiler that it should perform an operation. In this case, we have two expression statements. These are something that we'll get into expressions later, but these are a special type of statement that is an expression followed by a semicolon. Almost all statements end with a semicolon. And these two statements are separated or delineated by the semicolon at the end, meaning that they don't necessarily have to be on multiple lines. But both of these statements represent, or all statements are going to represent executable code. Or most statements, sorry. Stuff and things, words.
Exactly. But the most important thing to understand about statements right now as a complete beginner is that just about all of them, there will be special cases in which we'll discuss, must be terminated with a semicolon at the end. That is going to be one of two of the common mistakes all of our true beginners in this class will be making on a regular basis, including, wouldn't surprise me if even today it occurs, and that's going to be capitalization, so something that should be capitalized but it's not, or vice versa, and the other one is going to be missing terminators. So make sure, if I was to jump back over here into Visual Studio real quick, leaving off a terminator is a bad thing, because if I try to compile it now, it's going to tell me that there are build errors, and I can't run it. But you can see down here in my error list that it is telling me that a terminator was expected. So right now, this is obviously very easy to see because we're only dealing with just a few lines of code. But once you start dealing with hundreds or thousands of lines of code, it's easy to make mistakes like that, and you need to really stay on your toes.
Can I answer a quick question, though? I don't necessarily know if it's going to be quick, but this is a kind of fundamental question that I particularly remember myself having when I started programming. Okay. Marie asked, what I have problems is taking an action such as give this player a health bar and turning that into code. Now, the process of doing that is what programming is all about. What you need to do is you need to define what exactly, in a very imperative language in your mind, the steps necessary in order to accomplish a goal. And then you use a programming language such as C# in order to get those imperative statements that you have collected, those imperative rules, and encode them into a programming language. And how you actually do something like give a player a health bar is entirely up to you. There's many ways to do it. So the entire process of programming and what you will hopefully get out of this class, the goal of what to get out of this class is to have the tools necessary in order to express that kind of logic to a computer, and also have the tools necessary in order to pick up a problem that you want to solve and turn that problem into a list of imperative steps that you can then encode into a programming language.
Okay. So statements, pretty straightforward. I mean, I'm going to continue letting Nelson give his little descriptions, but for those of you that have been with me in past classes, you know I try to keep things extremely simple when it is when it's a 101 class. So the extra knowledge is a good thing. Just don't let it confuse anyone. So next thing I wanted to talk about, and this is going to be critical to Nelson, to Gavin, to myself, and that is going to be white space/formatting.
Oh, please, please, please. If you want to drive me insane, ignore that.
This is something that Toastage, as I now look back over at BuzzNet chat right now, who's going, white space. White space is extremely important. It is not anything that the compiler cares about, but it is something that other programmers, including yourself looking at your own code, care about greatly. So if I jump back over here into Visual Studio, white space is basically characters that do not have any sort of visible output character when used. Examples: hitting the space bar, hitting tab, hitting the character return. You don't see an actual character being placed up on your screen. That stuff is extremely helpful in formatting your code in such a way that it's easy to be read. For example, let's take out formatting that I have in here right now. So if I was to highlight lines 5 through 9 and just hit Shift Tab and then Shift Tab again so that everything is now left aligned, it becomes much more difficult to read this program. Now, granted, this is a very simple program, so it only takes looking at it for just a second to be able to identify what's going on. But in any sort of complex application, or it doesn't even have to be a complex application, just something that's, got 50 lines of code or so, having no formatting in place is just absolutely horrible because it does make readability almost impossible. I mean, I could go in here and make Toastich happy and even do something like this. How you feeling, Nelson?
I might vomit.
Hang on, let's get one better. How about that? There, Toastich, just for you, my friend. So we now have everything on one line. If I come in here and hit F5, you'll notice I'm still executing the application with no problem whatsoever. The compiler doesn't care about white space. All of that gets removed. But we, as the developer, we care a great deal about it. So let me go ahead and put some formatting back in place. Whole bunch of quick undos. There we go. So let's take a look at what formatting we have going on here. First of all, we've already mentioned these curly braces, and inside these curly braces are blocks of code. And I like explaining to beginners that you can kind of look at the blocks of code as being code that belongs to whoever's used right before the curly braces start. And now curly braces could be just used completely on their own, but generally when you're using curly braces, you're using it because, like here, a class. We need to define a block of code, in this case, this code right here, that belongs to the class. Now here we have a method, main. Again, we have an open and a closing curly brace. This block of code inside of main belongs to main. You'll notice how we're using tabs to indent. So once we have our open curly brace right here, we're then indenting one level inside, and then we start typing whatever we need to type. So this, in this case, just inside this open curly brace, we're going to be typing in members of this class. So this main method is a member of this class, and we'll get more into that a little bit later, what members are. But it's indented. And the nice thing about that is just quickly looking at this program, my eyes are able to trace this indented section here back to the first place it's not indented, and from that I can quickly see who it belongs to. So I can quickly see that main belongs to the class my program. And the same thing applies for main itself. So inside this main method, we have, again, an opening curly brace and a closing curly brace, defining all code inside as a block of code that belongs to main. So again, you'll notice that once we step inside of this block of code, we indent. So we're indented over another level in, so that if we were looking at code inside of main, we can quickly follow it back up to the first guy, being open parentheses, that's not indented, and I can see who that code belongs to. So Nelson, do you have anything you want to add on white space?
Well, there is a question that came in that I'll answer in a second, but I do want to point out a few things. First of all, I always find it, with beginners, the formatting, once you start coding for a while, formatting will all become natural. If at the beginning of this class you've never written a line of code, the code's probably going to look relatively cryptic with or without formatting. So I see a lot of beginners who don't format at all. I just want to stress that practicing a consistent formatting style, represented with what Jason has on the screen, is incredibly important, even if you don't understand the implications yet, because you will. The second thing I want to point out is that by default, Visual Studio indents with spaces, not tabs, which is very annoying. You can change that setting, and if anybody's interested, I can tell you where that is. The third thing is that there's a question. Do you have to take into account what should be first in the program and what can be 16th in the program? And the answer to that is when it comes to members of a class or classes themselves, the answer is no. When it comes to statements inside of a method, the answer is definitely yes. And we'll get to that eventually once we start talking about members. But if you're familiar with C++, you might be used to having to declare things in a certain order. In C# you don't.
Which is very nice.
Yeah. Toots, whatever. What about static void main with the first curly on the same line with the method definition? Please, I do not like that. Some people do. I'm just going to throw it out there that is a common thing you'll see in a lot of different languages, but that is not the formatting style that Microsoft itself recommends for C#. And if you want to be consistent with the majority of other C# developers, then you will more or less conform to exactly what Microsoft recommends, with a few exceptions.
And we will be getting into all of the actual conventions as we work our way forward. Right now, I just wanted the simplest app up that we could get up.
Well, yeah. C++ developers also. I've seen C++ develop. They do whatever they want. I mean, see, the thing about C# is that it's more or less kind of controlled by a single company, and they kind of have like these guidelines that are used everywhere. C++ is, yeah, I've seen weird formatting styles from C++ before. Those developers get crazy. For C#, I would highly, highly recommend to follow that formatting style that you see on the screen.
Yes.
Someone would like to set it to tabs, not spaces.
Here, if you remember where that's at right off, I'll let you just have it.
Alrighty. Where are your Visual Studio? Okay. Actually, I'll just show it right here. So by default, it's spaces, as you can see as I select this line. These are all spaces. Now, the shortcuts that Jason showed you are still applicable. So if I hold down Shift and hit Tab, it will indent properly. But if you want tabs instead of spaces, which I personally prefer, and I think Jason does as well, you can change that under Tools, Options, and you can go down to wherever you change the line numbers. It's going to be under Text Editor, All Languages. Now, remember, if you do not see all languages, make sure to hit this checkbox down here that says, yes, I'm in the options window. Of course, I want to see all the options, because otherwise, why would I be here? So just hit that checkbox, and you will get the all languages menu item. At that point, head down to tabs, and go ahead and say keep tabs. Once you hit OK, it won't automatically convert anything, but if I go ahead and unindent this entire line, then reindent it, you will see that we now have tabs. I've heard about 3 spaces and about 4 spaces. What about that? I've seen a lot of Ruby developers like 2 spaces. Most everybody else prefers 4 spaces. I've never seen anybody prefer 3 spaces. I think that would drive me insane. So either 2 or 4 is generally the preferred indentation level.
And yeah, I agree. 4 is definitely easier to read.
Yeah.
Okay.
So yeah.
We'll go ahead and
also, just a heads up, if you guys have questions, there's a question feature inside of BuzzNet, so that we don't lose questions as they scroll by in the chat, and you can access that with the little question mark icon on your toolbar.
That be the one. All right, so let me go ahead and switch back over. Okay, so let's see, where were we at over on the whiteboard? So white space and formatting, very important. Please make sure to, oh, cool, thank you. So Mary, thanks, Mary. So moving forward, the next thing that we wanted to talk about is going to be naming conventions. You know, naming conventions is interesting because there's a lot of things to talk about in regards to naming conventions that you still need to know about. But we can talk about naming rules real quick with identifiers. What do you think, Nelson?
Yeah, you mean identifiers in the context of inside of a method?
Well, I'm talking about just identifier naming in general with not being able to use like numbers at the beginning as the first character.
Oh, okay. Yeah, definitely.
Because that's still something good to note.
Yep.
Actually, you know what? We'll actually come back to that. Since we are going to get into some variable usage, we'll come back to those identifier naming rules when we get there. All right, so next thing I wanted to mention, which we've already talked about a couple of times, are methods.
And someone asked a question earlier in the thing, is a method like a function in C++? The answer is yes, if you know what that means. If you don't, ignore me.
Yes. And for those of you that are coming from, like, let's say Mel over in the Maya world, a method is like a function there. Well, actually it can serve as a function and a procedure, where functions have return types and procedures do not. Though with our method here, we do have some sort of return type always designated, be it a void or a given specific type. But again, as mentioned earlier, a method is nothing more than a block of code that is designed to perform a specific function. It's as simple as that. We're going to be using lots and lots of methods as we work our way forward. And that's generally the first place that people start having, that are complete noobs, begin having difficulty. Types. This is going to be something else that you are going to hear a lot. You've already heard us mention it several times. Nelson, give a quick description of what a type is. Let's see how you can do for a quick description.
Oh, man. Actually, funny thing is, formally defining a type is a very difficult thing.
Yeah.
Even one of the developers of C# actually wrote like a 3-page article about what exactly a type is. But at a fundamental level, a type is, I can define it in a different way. Everything in C# has to exist in a type. A type provides reusable functionality that you can define. And the different categories of types provide different types of reusable functionality you can design. You can use to write code. Console is a type. Program is a type. Both of them are the same category of types called classes, and we will definitely be getting into different kinds of types a lot later. But a type is anything that defines. So just again, a type is anything that defines a set of functionality that you can perform on. You can make your own types, and you can use types from other people.
So where class program, that's our own custom type.
Yeah, Big Chuck actually said something interesting. So types equal nouns. And yeah, I mean, if you want to think about, one good way to think about it is we've already defined a method as a grouping of functionality. A method is usually going to be what you could consider a verb. A type is going to be something that you would generally have as a noun.
And I do believe we have videos where we've talked about that in the past.
Is ReadLine a type? No. ReadLine is not a type. It is a member of the console type. There's no way in C# to access the ReadLine member of console without explicitly saying console dot. You can't say using console. You can't do anything like that. You have to always type out console.WriteLine because you need to specify that you want to operate on the console type and in particular the WriteLine member of that type, right, or the method of that
and
type.
Speaking of methods, how we had mentioned that main was a method. Well, WriteLine, well actually let me take it all the way over. WriteLine and ReadKey, both of these guys right here, are methods. They are methods that are members of the console type or the console class. Okay. And earlier we had mentioned, or I had mentioned, how main in this case does not take any parameters in. We can see down here that WriteLine does take some information in that it will then utilize in performing the action that WriteLine does, which in this case is to write something out to the console. So the information that method, WriteLine, takes in is going to be what's used to write up on the screen. So we'll write hello to the screen.
Another question came in. Are the words type and class the same? And the answer to that is no. I hate saying the sentence. A class is a type of type. A class is a category of type. There are many different types of types. Again, I hate that. There are many different categories of types, different kinds of types that you can use for a variety of purposes. classes are just one of those kinds.
Enums, delegates, interfaces.
Yep, structs.
Structs. Kind of some of our
Someone also asked in the question area, do you know how soon the course will be available recorded? I've got to run, or should I just come back on Thursday?
You're welcome to come back on Thursday, of course, but if it does not go up live tonight, it will go up live early tomorrow. So one of the two.
Big Chuck, you can think of types as being nouns and methods as being verbs.
Yeah.
Now, once we get into variables, I think there's a better way that I can define what a type is. So just keep that in mind.
Agreed.
One of my favorite ways of actually specifying what it's. I mean, I could just say it now and we can restate it.
Go ahead and say it. Just plant the seed.
A type is anything that you can have as either a variable or a parameter. A type is going to be something you can act on as a variable or parameter, period. So anything that's a type, it's a little bit, I'm not going to say, anything that's a type, let's just keep it simple, can be used as the type of a variable or the type of a method parameter.
So again, I did underline the types that we see here with program and console both being underlined. Of course, main is not because that is a method. All right, so go ahead.
In fact, I've just pointed out that Visual Studio Colors types bluish, and that's true.
So one more thing that I wanted to mention before we move out of this kind of introduction to the syntax fundamentals is namespaces, because namespaces is something that we're going to see a lot.
NATO just said something.
Okay.
He said, is using a type? No, using isn't a type. Neither are namespaces. Using is a keyword that specifies in the context when it's above all your other classes at the top of the file, the using declaration, which is going to be just telling the C# compiler, hey, I want to use all these types in this namespace. Don't make me retype the namespace out every time.
Right. And then as far as namespaces go, we've already talked about them a little bit earlier. Nelson, if you want to go over it one more time.
If you think about types as files and namespaces as folders, I think it's a good way to think about it. They're simply an organizational mechanism that allows you to place all of your types that you create. Remember, in C# you only can create types. You can't have free-floating code, period. So you place all your types into these things called namespaces, and they're containers that you can use to differentiate your types from the types of another namespace so you don't get name collisions. A system is an example of a namespace that contains many types that you can use, such as console, and so on.
Okay, and then from here, was there any other questions over there?
Is Hello World not a type?
That's interesting.
Yeah.
That's the data that's being stored in a type.
Right. The C# compiler we'll get to strings later.
But it's data that gets stored in a specific type. In this case, it's going to be a string, which we will be talking about those in this video. But yeah, I love that question because it's kind of a tricky one.
Well, because the C# compiler actually does something behind the scenes whenever it sees double quotes, in that it magically wraps that into a special type of type. But yeah.
So let's move on to another interesting discussion real quick, which we've already talked a little bit about, but that is introduction to .NET itself. I mean, we've been working through all this stuff for the last couple of hours, and the most important thing that we've mentioned that relates directly to .NET is a managed language. And we've also mentioned the CLR, the Common Language Runtime. But first question, Nelson, why even have .NET?
Well, at a very, very, very fundamental level, Microsoft wanted to create the best programming language and the best platform ever, and they did.
How about let's back up to the somewhere around in the late 1990s when Windows programming honestly became a mess. Your typical languages that were being developed in, you had Visual Basic, you had C, you had C++, and programmers were using raw Win32 API calls, which required all sorts of setup and was a bit complex.
Yeah.
They had the MFC, or the Microsoft Foundation classes. Now, the Win32 API was not object-oriented, and the Microsoft Foundation classes, while it was object-oriented, there was a lot of inconsistencies and issues throughout that entire beast. I'll just call it a beast. And then there's Nelson's favorite also that people were making use of in the late 90s, and that's the good old component object model, or COM.
Nope. That was a terrible, terrible idea.
Nope, no vomiting, Nelson. So in theory, it was supposed to be very simple, but it ended up being quite complex and needed some really nasty plumbing in place to make use of. So, like I said, let's back up to the very late 1990s, and that was kind of the state of the programming world for Windows. It was just a big mess, and Microsoft wanted to rectify this. You want to take it from there, Nelson?
Yeah, they wanted to take all the problems, all the common problems that developers have been having, and create a very streamlined and simple way to solve those problems. In particular, COM was designed specifically to allow multiple languages to communicate between each other in a consistent way. So in theory, it was a very good thing. The problem is that because they were still working in a native environment, they had to do, like Jason said, so much plumbing to get that realization to happen, where you have multiple languages all talking together at the same time in a consistent, clean way so that you can reuse code. That's the big thing, being able to reuse code in a consistent way between languages. So then they invented the .NET framework. They invented the .NET framework so that you could have multiple languages, the potential multiple runtimes, and have a consistent programming model, or the common type system, and the intermediate language, to have interoperability between all various forms of languages, and also to define a standard and consistent and clean way to access all of the functionality that Windows provides, such as accessing the Win32 library or doing other things that were traditionally very difficult to do. So they invented the .NET framework to be very clean, very straightforward, to make code reuse a possibility, to get rid of DLL hell, to make interoperability between languages, to do all sorts of things. And it was a very, very ambitious project. And they basically took a lot of hints from Java in the early days, but have extended .NET much, much further than Java has in the last 10 years.
Speaking of Java, I'll throw this in as well. Back in the late 90s, web programming, was it something that was really being looked at and considered for those that were Windows developers? And that's something else that also came heavy into the planning and creation of .NET.
Oh yeah, web development with .NET has been a first-class feature since version 1. They wanted to compete with, the big guys back then were basically just Java. Then you had a few toys like PHP, 3, 2, and Cold Fusion, 1, which, Cold Fusion is still a toy language anyway, but PHP has obviously grown since then. But they really wanted to provide a very clean and straightforward way to make, a very powerful way to make web application development a lot easier, using all the same technology that you would also use to create Windows applications or Windows services. Mm-hmm. So they encompassed all of these potential use cases into the .NET framework. So it's a very well thought out standard that provides functionality in a variety of different areas, and the C# language itself in particular is quite possibly the most modern language that is in use today. And I say that I don't consider Java to be a very modern language just because the specification has been stagnated for so long, but C# has consistently been updated and reworked and improved, and is now, like I said, probably the most feature-rich language that is in popular use. There are more feature-rich languages than C#, but they're not as popular.
If you really, really want to take the .NET framework and just kind of condense the whole thing, one, you can say it's a managed execution platform. And within that managed execution platform, it contains an execution engine, which is also known as a virtual machine, which is going to be in charge of code generation. So your JIT compilation that we talked about earlier. It's going to be in charge of security. It's going to provide runtime services, things like memory management. We'll be getting into garbage collection and all a little bit later, I/O, etc. Also, in the .NET framework is supplied a set of classes that we can use. We talked about the BCL a little bit earlier, and the thousands of classes that are waiting for you to take advantage of them. And then governing the whole thing is nothing more than a set of standards that's describing the standards that each of these things must comply with. Now,
yep, and they're all,
go ahead.
Yeah, the standards, they're just text files that have been, immortalized as a standard.
And now we can get much deeper into .NET, but that would be something I would prefer for us to do a little bit later on, because those of you that are completely new to programming, that'll just do nothing but like blow your mind. So, all right, well, with that quick discussion about .NET out of the way, now it's time to get back into a little bit of coding. Now, on the syllabus that we had, the next thing up was the ReadLine or reading and writing to the console, and we've already looked at that. We've taken a look at the console member WriteLine and ReadLine and ReadKey, and we saw that WriteLine will allow us to send some information in to the WriteLine method, and that information will then get printed out to the console. And ReadLine will sit there waiting for a user to hit the enter key before taking in everything that they typed on that line. And ReadKey will just simply sit there and wait for the user to press any key. Now, simple enough, but at this point, we haven't really given ourselves the ability to save any sort of information so that we could turn around and act on that information. And that's kind of one of the core concepts that you have to understand in writing any programs, is that we need the ability to save stuff, to save information. So what I'd like to do is go ahead and give a very quick introduction to variables. And there are two types that we're going to look at, and they're going to be string and int. So let's go ahead and give myself some room down here. So int and string. Now an int is basically, this is going to be an integer type. Well, let me back up. Let me say it like this. When we want to store something in memory that we're then going to turn around and use later, such as if I was to come back over here to our little program and was to say something like, what is your name? And then I wanted somebody to actually give me an answer. So I'm going to do a read line, which is going to read information back in. Now let me do one more read key down here. This will make more sense in a moment. So I'm wanting to ask the user with this program, what is your name? I want to wait for the user to type in their name, and then I want them to hit enter, and I want to hold that name somewhere. I want to store it. And then I want to do a read key, which will then basically terminate the application, because that is at the very end of main. So if I hit F5, it's going to say, what is your name? And I can come in here and say, Jason Busby. All right, typed in my name. Hit enter. And that was the read line that was waiting for me to hit enter. But I didn't do anything with that line that read line just read. So at this point in the program, we're now sitting right here at read key. So as soon as I hit any key, we're going to terminate the program itself. So if I wanted to actually store this information, and Nelson, I just want to say this ahead of time so that you don't give me any vomiting sounds. We're going to start out with explicit instead of implicit, okay?
No, that's
okay.
Fine. I would have done that as well.
So I'm going to come in here, and again, to those of you that are complete beginners, don't worry that this looks Greek. I'm going to break it all down for you in just a few minutes. I am going to come in here and I'm going to create a variable. This is a local variable. It is local to the main method. See how it's being defined inside of our open and closing curly braces, meaning it's in main's block of code. But I'm going to create a variable type using my own name that is going to store whatever was in the line that the user had typed when the user hits the carriage return. Now I'm going to prove that it actually stored that information by turning around and writing it back out to the console. So I'm going to say console, and I'm going to tell it to write line, and I'm going to simply say name. So the idea here is that whatever you write right here on ReadLine, once you hit enter, that gets stored in name. Then we turn around on line 8, and we're going to call console write line again to write out whatever was stored in name. So let's go ahead and run the program real quick. So again, what is your name? Jason Busby. And if I hit enter, based off what my code is telling the computer to do, it should basically echo this back at me. So I just hit enter, and it did just that. It echoed it back out at me. Now execution is sitting right here at the read key, so the moment I hit a key, execution is complete. So there are a few things that we need to take a look at. First of all, let me break this up a little bit. And as a matter of fact, I'm going to go ahead and reset the ready checks and let all of that get out. All right, there we go. Here's what I want you guys to do. I am going to put my string name up at the top. So you got string name, and then change your console write line to say, what is your name? And then on line 9, now I'm actually using name. I'm using it to store some information. So go ahead and do that real quick. And then once you're done, go ahead and click your ready check. Segfault, be careful not to get too far ahead with people. I don't want anyone confused. We'll get to concatenation in a few minutes. Okay, so there's still a handful of you guys that have not yet clicked ready. Again, once you've typed this out, go ahead and hit F5 and make sure it works. And if you get stuck with any problems, just let us know over inside of BuzzNet. And once we get through this, I will jump back over into the whiteboard and break down variable usage for you. Segfault, do not fall for Toastage's questions. Nice try. Okay, just a few more of you guys left. So again, make sure you click your ready button. Okay, so guys, anyone, if you're having any trouble, please make sure to post over in BuzzNet. Otherwise, check it, because we're about to go ahead and move on. Or how about, say, 1 more minute? Does that work, Nelson?
It should.
So, yeah, click the 1 more minute. Otherwise, if I don't get the 1 more minute, then I'll assume that you forgot to click the ready button. Okay, awesome. Thank you. Hey, Nelson, it works.
Yeah. It's actually been, I mean, like I said, it's as far as at least the server sides, there's been no stability issues whatsoever.
Hey, Enrico and Big Chuck, make sure to click your ready button if you guys are done.
I mean, are you really surprised that the code I wrote works?
Thank you, Jen. I didn't say anything. Jen said it for me.
Listen, we're probably getting indexed by a search spider.
Big Chuck, if you're just watching, go ahead and hit your participate button again. That'll pull you out of participation, and then you don't show up on the list of participants. Yeah, perfect. Okay, again, so if anyone's having any trouble, had quotes around my name, so it didn't work. That's a very good point. You'll notice right here that there are no double quotes surrounding name. It's all good, Big Chuck. You're welcome, sir. Here we're actually explicitly using our variable. We're using our name identifier.
Yeah, well, again, that kind of comes back to what the C# compiler does behind the scenes when you use literal quotes. And it basically does something that you're now seeing with the identifier, just without an identifier. It's creating a string in the background and then assigning the string to whatever you type in double quotes. You just don't see that because the C# compiler does it for you. So the double quotes are just a special syntax that you can use. Normally you wouldn't use them when passing in parameters if the parameters are variables.
And Enrico, is everything good? Just checking in with you real quick before we continue forward.
Is there a capitalization convention for variables? Yes. Generally speaking, variables, local variables inside of a method will always be lowercase.
So let's go ahead, and I'm going to assume that Enrico has stepped away from his computer at the moment. Not a problem. Let's go ahead and jump back over into Photoshop to the whiteboard. And a couple of things that I want to talk about real quick. So first of all, we know that the idea of a variable is to store something. So I'm going to say, here's my memory. See, I have a whole lot of memory. Yay. And I want to store some information in it. Now, for those of you, Segfault and others that happen to understand the heap and the stack and stack frames and all that good stuff, those are things we're going to be talking about a little later. This is very generic at the moment. So in creating a variable, the first thing that we need to do is to declare it. And the way that we declare a variable is going to be by specifying a type, and actually since we used a string, let's go ahead and use string here. And then identifier. So here's that pesky thing we mentioned earlier, a type. And identifier, this is basically going to be how you want to identify that memory location with a friendly name. Very simple way to put it. So in our case, we wanted to store somebody's name, so we used, and of course, let me go ahead and put a terminator at the end here. So when we had declared our variable, we used type, and our identifier was name. And you can think of it in its most simplistic way as a place in memory has been set up that we can now access, and this place in memory, we can get to it by simply accessing name. And it's no different than, I mean, in the past, you guys have all seen basic algebra stuff when you say x equals 5, and then if you turn around and say, hey, what's x? You would say 5. It's the same thing that's going on here. We have what is called an assignment operator. And this assignment operator, it's basically saying to put whatever is on the right into whatever is on the left. And what we have on the left is something that will hold information of a specific type. Now, of course, in this example here, I'm just talking about in just general algebra terms. But, I mean, if we were actually doing that as a memory location, we would have had to have first declared a variable called x, which since I would want it to hold, in this case, I know it's going to be holding an integer value, a whole number, So no decimals allowed. So I'm going to set up as an integer, and I'm going to call it x. So in this line here, we have we have declared our variable, and in this line here, we've used it. It's really that simple. So if we were to look back in memory, we now have another place that has an identifier of x, and in this case, it has a 5 stored in it. So if I was to turn around here, and now here's my super crazy shorthand, console.WriteLine, crazy shorthand, people. And if I was to say write out whatever is in x, it's going to write out a 5. Even though it's not a string, it will automatically convert that over to me. And we'll get into that kind of stuff a little bit later on. So back down here with this crazy example, we've got a declaration, string, so our type, name, our identifier, terminator, so that's the end of our statement. So on the next statement, I'm going to say name equals console. Again, this is major shorthand, which, wow, it took forever for that to show up. Console.WriteLine, or excuse me, my bad. The long lag there kind of blew me away. So we're going to do a read line because we want to read information in. And then we'll do open and closing parentheses. Now keep in mind, this is just a method we're calling. ReadLine is a method. It's a member of console. And so if I was to turn around on the next line, so let's say I just typed in buzz. When this line here happens, buzz would actually be stored in memory inside there. And then after hitting enter and that assignment was done, Nelson, what was that? That was a loud popping sound. That was bizarre. The next line, let's say I wanted to do a console.WriteLine, and I want to print out whatever is inside of name, whatever's being stored there. I would just do that. And then what's inside of name, that information right there is the information that is going to be written out to the screen. And so it's going to be buzz. Yeah, okay, so there's a few other people that heard it too. Sounds like a soda can, an audio pop. Yeah, with some sort of loud, trebly popping sound. So variables, it's that simple. And this is the very first place that our beginners start to have a little bit of difficulty. You just have to remember that they must be declared. You've got to tell the compiler about them. And then you've got to give them a friendly name. They've got to have some name so that you can turn around and use that name when working with them. Nelson, is there anything you want to add on top of this before we jump back over?
No, I mean, definitely talking about instances where you might try to assign console.readLine to an integer might be a good example for a little bit later.
Sure.
But
actually, no. There is something big that you want to talk about here. I'll get into the rules of identifier names in just a moment, but I want you to get into how important it is to name your identifiers in such a way that it makes sense in the context of their usage.
Well, yes. I mean, variable naming is one of the most important things ever. And I'm not just in this case talking about local variables. I'm talking about also variables that may be a member of a class, which isn't something we'll be going over. But I just want to point out that what I'm talking about here extends further than what you just have here with local variables. But if you do not assign a good name to a variable, then you are doing it wrong. The variable should speak for itself. It should tell whoever's reading it what that variable's purpose is. And you should always make sure that your variable names are consistent as well. Like, for example, I saw someone was typing out code in the chat, and they did, console.WriteLine hello plus name plus space plus L capital name. And that kind of naming style isn't very appropriate for that particular situation. And the reason it isn't is, first of all, L name is an abbreviation for last name. Abbreviating variables is a very bad idea. You want to make sure that your variables are, the compiler doesn't care how long your variables are. And as long as you're within reason, naming them as long as you need to in order to get a very descriptive language out of your code is very important. Another problem that I have with saying hello name plus lname is that name itself doesn't actually describe what is stored in that variable. First name would describe what's in that variable. Name does not. So those are those are two concrete examples of where I think you should definitely put more thought into those kinds of variable names, because code bases get huge. They get very, very big very quickly. Being able to read code, you will be reading code more than you will be writing code. You'll be reading code, navigating code, and editing code a lot more than you'll be writing new code. And if you took the time to give a consistent language to your code, to your program, actually being able to read through that in a future date will be a lot simpler. And throughout this course, I mean, even in the intro course, I do definitely want to, at the very least, describe what kinds of tools you can use in order to make your code straightforward. And the first one that we have here is naming your identifiers something appropriate.
Agreed. We wouldn't want to go string X and then ask for someone's name.
Yeah, and I've seen people who do like X and then X2, X3, X4, X5, and it's like, really?
All right, some quick identifier rules. Okay, so simplest way to show this is let's pretend that this box contains, well, I'll just do this, name, N-A-M-E. So that's the identifier that I used with the declaration up above of a new string. So this first box is going to indicate how we can basically work with the first character, what's allowed, what's not allowed. And then this last box here, this is everything else that's left in the variable name. So first thing to understand is what is allowed for the first character. We're allowed lowercase a through z. We're allowed an uppercase a through z. We are allowed an underscore. And we are allowed the @ symbol. Not allowed. Not allowed, we're not allowed to use 0 through 9. We cannot start off with a number. Now for right now, what I want you guys to focus on when you are doing your identifier naming is just use the lowercase a through z or the uppercase a through z or the underscore if you feel it absolutely necessary. That's going to have, are you going to use the C# specification for everything, Nelson? Fields?
What do you
fields?
mean? C# specification for everything?
The recommended usage of naming for fields?
Well, I think that should always just be a lowercase a through z or an @ symbol, not an uppercase or an underscore.
Oh, agreed. I'm just talking about because you love to use your underscores when doing fields.
Oh, well, I was talking about local variables.
Okay, I'm just talking about naming in general with identifiers.
Okay, sorry. In that case, yeah, underscores I do use for local fields.
I just don't want anybody to get confused a little bit later on. We will when we start getting into heavier usage of this. We'll go back over like should all be lowercase, or if it's public fields, uppercase, or properties, uppercase, etc. But we'll wait till we get to the right situations for those. Right now, this is just a general identifier naming set of rules. So for all of the remaining characters that are left in the identifier, what is allowed is going to be, again, A through Z, lowercase, capital A through C, an underscore, and wrapping around, also 0 through 9. What is not allowed in the remaining characters after the first character is going to be, take a guess, our @ symbol. All right, so Nelson, was there questions coming in?
Just someone said that, do you want to see lowercase names for variables, right? For all the variables that you will be creating, at least,
yes.
Yeah, for the local ones, yes, definitely.
Okay, so very simple rules for naming. Now I do have a quick thing for you guys to all hammer out, and I'm going to hit the reset ready button just to get everybody ready to do this exercise and hit reset. Do I see Toastitch is not following? All right, so here's what I'm looking for. Let's jump back over into our application. You've seen how to go about declaring a local variable, and we're using the terminology local variable because it is local to the main method. It is part of the block of code that belongs to main. What I want you to do is write a quick program that asks for your first name, and then it asks for your last name. We'll go off what Nelson was talking about a few minutes ago with naming. And then I want you to console write line it. I want you to write out the first name, and I want you to write out your last name. And then once you've done that, make sure you have a read key and hit that you're complete or ready over in BuzzNet. So it's going to ask you, basically I want you to store your first name in one variable and your last name in another variable. So it's just going to ask for your first name and it's going to ask for your last name. And then it's going to do two different write lines. The first write line will write out whatever's stored in your first name, and the second one will write out whatever is stored in your second name. As far as if you should declare it first and then use it later, that's completely up to you. I'll be discussing both in just a minute. So I'm giving you guys your first opportunity to think, for those of you that are truly new to this. No, we're looking for no concatenation at the moment. Concatenation. We'll talk about concatenation in a few minutes. So how's the weather up there in Seattle, Nelson?
It was snowing this morning and last morning. Oh, wow. But then it all went away.
Wow.
I know. I like the snow. I like the cold. Still no errors on the server side.
That's good. I do notice the lag kind of showing up every now and then.
Yeah, but I really think that has more to do with the net more than the program itself. I mean, there might be some things I might be able to optimize, but it's probably mostly to do with the network. Because, I mean, it's the same server that runs 3dbuzz.com,
right.
So.
All right, so our list is slowly dwindling down. Good, good, good. Do you see what NATO's saying?
I think the lag is caused by ready checks. I notice it's worse when people are using it.
2 meters of snow outside my window. Wow.
I would love for that. I love the snow.
That's a lot of snow. All right, so I'm going to give just one more minute, and then if you're not done, that's okay. I'm going to work through it on the screen so that you can see what I was looking for, and then that will allow us to discuss a couple of different things. 7 feet. Woo. Yeah, that's a lot of snow. And so we're almost there, just another minute. What are you playing with, Nelson?
Oh, what I was talking about earlier. It's still the only thing on my desk that I can play with.
Okay, so we'll see you, Big Chuck. Take care. Well, thank you for posting it there, Gavin, as opposed to in the channel, because I want to make sure that the people that are new are seeing just the new stuff. So the question button, Nelson, we had a question come in about how does that work?
The question button? The one on BuzzNet? It'll only submit the question to us admins. So it's just a discrete way to shoot over questions that we can see.
Do you not have a splitter bar between the two?
I was going to, but I just had flashbacks of using splitter bars before with WinForms.
Really?
And yeah, because it has to do with the order of the z-index of the controls and whether or not they're docked properly, and it has a bunch of weird things, and I don't know. But the UI I haven't really focused on right now. It's going to be focused on. I want this to look a lot better.
All right.
But getting it functional is more important, I think.
And yes, Gavin, only Nelson and I could see those that are submitted up there. So if anyone is still having any problems, let me go ahead and type this out now. So I'm going to do it in the most simplistic way possible. First thing, based off what we've already discussed, we want to make sure that we have identifiers that make sense for what it is we will be using those variables for. So in this case, I'm going to do first name. And as it has already been mentioned, you'll notice first name is starting off with a lowercase letter. Very important. Again, it's just a convention, but it is a good one to follow. Also, next thing I want to point out is what we're using is a casing that's called Camel casing. And Camel casing is where when we have multiple words that are tied together like this, the very first letter of the first word is lowercase, and all of the remaining words, their first letter is uppercase. And again, that is camel casing. So if I had first name for my invite, notice how first character is lower, the next word, first character is upper, next word, first character is upper, next word, upper, next word, upper. Pascal casing is going to be almost the same, except that first character is also uppercase. So in this case, since it is a local variable, the convention to use is going to be camel casing. So I have created a variable, a local variable called first name that can hold a string. Now let's create another variable. We're going to call this one last name. And now I'm going to update my console write line to say what is your first name. And I'm going to use the correct variable here, first name. And you'll notice Intellisense automatically picks up on what's available as you start typing. So I can just double click that or hit enter. And now I'm going to do another console.write line. And I'm going to say, what is your last name? And I'm going to simply assign last name equals, again, we're going to do a console.readLine and allow the user to type some information in and hit enter, and whatever they typed in will get stored. And then finally, I'm going to write out whatever's in first name, and then I'm going to write out whatever is in last name. So again, for readability's sake, I'm just going to put some white space in there. So I'll separate my variables up top. I'll separate my two groups that deal with my first name and my two groups that deal with my last name. And I'll bring the size down just one so it all fits. And yeah, that works. So again, I am creating two variables, first name, last name. And then think about it. Remember, execution simply walks forward. So first name, then we execute the next one, which is going to be last name. So now we have two variables that are set up locally that we can use inside of main. The white space is ignored. Then we jump down here to line 10. So then we write out what is your first name. Then execution jumps down to line 11, which sits there at an assignment. We're sitting at the read line. So in the console, the cursor's flashing, and it's just waiting for the user to type something in. And the moment they type something in and hit enter, whatever they typed in is then read, hence the name ReadLine, and put inside that variable. Once that's done, execution then jumps down to line 13. And on 13, again, we're going to write out to the console, what is your last name in this case? So once that's written out, execution again jumps down to line 14. In line 14, we're sitting there once again, we're waiting for the user to type something in and hit the enter key. Once they've done that, they hit enter, that line is read, and the data is placed back over into last name. Then we simply write out the first name. We write line again the second name. And then we wait for somebody to press a key. We wait for the user to press a key. And I had a question come in about what if I want the last name on the same line as the first name? We're going to do that in a second. We're going to use concatenation to do that, but I like to build up slowly. Because believe it or not, there are a lot of people out there I've met in the past that are new to programming that have trouble with the simple concept of concatenation. So if I go ahead and I run this, so it's your first name, Jason, enter. It's now assigned that to the first name variable in memory. What is your last name? Busby. I hit enter. Again, that's been assigned. And then you can see it's echoed out two lines, the first being Jason, the next line being Busby, and it's now sitting here at the read key waiting for me to press the enter button to conclude execution. Brislin, yeah, make sure that you do not put double quotes around your identifiers. And so with that in place, what exactly is the string type? So what is a string? It's alphanumeric characters.
And
symbols, yeah. Here's an example of a string. We've placed these inside the string inside of double quotes here to tell the compiler that this is a string. But if I was to come down here to where I'm actually using my variable first name and put it inside of double quotes, what am I doing? I am now treating this as a string. That's what you'll notice. Its color's now changed to a red color. It's now just being treated as alphanumeric and symbols characters. But I want to actually use whatever was stored inside of first name and last name, so I can explicitly use them right there. Gavin, we'll get to escape characters. Again, people that know code get really excited about wanting to jump ahead to even things that seem super, super simple. It's better to layer this on for the true beginners.
Well, Toasted is asking something that we're going to be getting to at some point. Were we going to be doing this time or on the next?
I didn't see.
He says, if I try adding an int variable, it freaks out on ReadLine.
Yeah, we can do that. Actually, yeah, we will do that. Okay, so everybody should pretty much have this and hopefully understand the concept of what's going on. Now, a question that was asked earlier was these strings that I'm declaring here, do I have to have them declared up above by themselves, or can I actually declare and use them, at the same time, all in the same line? And the answer is yes, I can. So if I would have come in here and the moment I need it, first name, I could have just simply said string first name. And if I come down here to last name, same thing. And then execution is going to be exactly the same. What's your first name? Jason. What's your last name? Busby. Enter, and it prints out Jason Busby.
Yeah, it's important to realize that when you, if you just had a string name at the top without any assignment, if you want to have that up there, just because
Sure.
I want to say something about declarations.
Okay, you're going to talk about initialization or default values?
Kind of. I just want to say that that line 7, for all intents and purposes, is not an actual line of executable code. The only reason that exists is for use in C# itself. It has no meaning really anywhere other than in C#. What that's doing is it's saying, all right, C# compiler, I want this name reserved for this type, and that's it. It does not turn into any opcodes or any other thing that gets sent off into IL. Now, it kind of does when you start talking about how the stack frames are initialized, but I don't think we're going over there right now.
Too far ahead.
Just for all intents and purposes, line 7 is not a line of executable code. When you add the equals, you are then adding in executable code to run on that line. So on line 13, that is a piece of executable code that says, C# compiler, reserve me the word last name, which is a string type, and go ahead and stuff the following things into that when you reach this line. So line 13 does execute code. Line 7 does not. So think about variables as reserving a name. It's actually called binding, static binding. You are reserving a name for future use.
Try not to throw out too many fancy words for our true complete beginners. I don't want them scribbling binding down in their notes.
Okay, well, it's reserving a name. You are reserving a name. Just that's the concept of declaring a variable.
Okay, so we have pulled in and stored a string. So what if we want to store a numeric value? Like we saw earlier, we had an int. Well, again, we've got to go through the exact same process of first declaring before we can use it. And so to declare an int, following the notes that I used on the board, the first thing we've got to do is type in the type. So in this case, the type is going to be an int, and I'll call it my number. So int my number. Of course, my number is an identifier, following the rules that I set forth earlier. And I now have a place reserved for me in memory to store integer values. But let's say that I wanted to ask, no, let's do this. Int my number, and I wanted to say, I want to do another console.writeLine. Actually, it's going to be a read line here. Let me put the information right above it, what it's going to write out. So let's say I do a console.writeLine, and I say, what is your age? Well, we're going to have a problem, because what this guy returns, our read line, he returns a string. And you can see that if you hover over console.readLine, you can see right before it string, and that is indicating its return type. But int is not a string, it's an integer. So we need to convert this string over into an integer. And there are a few different ways to do it, but we're going to go with the easiest in the world. We're just going to do parse. So we can do parse or try parse, but we'll get into try parse once you guys understand if and else's. Now what parse is, it's a method available to us on the int type. So method indicating, we have an open and a closing parentheses here. And then inside it, it's expecting us to pass in a string. And you can see that down here in its formatting. So here in the syntax for it, it's saying that it returns an integer, but the method parse takes in a string. So it's going to take whatever you type into readLine, which returns a string, and it's going to convert it over for us, if it can, to a number. Otherwise, it'll throw an exception. And we'll worry about things like exception handling a little bit later. But now I'm going to add one more thing. Go ahead, Nelson.
Are you sure that's the best name for your variable, Jason?
It's my number. Oh, wait. Yeah, that's right. I should have said enter your number. Let's change that to age. That is a good point, since we will be following along with that. And let me take int out here. And I'm now going to do a console.writeLine, and we'll just write out age. Now at this point, even though age is an int, it will automatically cast it to a string for me for writing out. So now we've set up variables for, as a matter of fact, I'm going to go ahead and do this with last name as well. Okay, so our variables up top, our declarations. And then we ask, what's your first name? We read it from the console and we store it. We then write out what's your last name. We read whatever the user types in at the console and we store it. We then ask, what is your age? We then read it from the console, so that's going to take place first. And then it's going to get parsed into an integer value, so a whole number. If it does not successfully convert it, it will throw an exception for us, and that's fine. But then that integer is then stored into int. And then we're simply going to write out first name, last name, and age. Actually, I'm going to do one more as well. And I know that Gavin's probably wanting me to simply use escape characters, but no. We're going to just do a blank write line just so we have a space. Super simple program. So let's go ahead and run this. So first name, Jason. Last name, Busby. Age, I feel like being 28 again. Hit enter. And because I put that extra console.write line in there, basically it just echoed out to the console an empty space, an empty line. And then there's everything being written back out by the 3 different console write lines. So you can see that we have indeed stored the information for first name, last name, and age. And we successfully handled age. Now for those of you that are getting all nice and crazy out there with wanting to put in super large numbers, when we start getting into more types and being more specific with types, we will start talking about limits, because integers can only hold so much. 32-bit integers, 64-bit integers, if you need bigger numbers, etc., etc. So let me go ahead and jump out of that. And I'm going to hit the Reset Ready button. And if everyone has managed to successfully follow through with this, let me bring the sizing down a little bit so we can see it all. Just go ahead and check Ready. Okay, most everyone. And then what I'd like for us to do, there's still a couple people that are wrapping up, is let's go ahead and take another quick break. Mary, go right ahead. For those of you that need to use the bathroom or get something to drink, now is a good time to go ahead and do it. I'm going to hit pause on the recording. Resume. Okay, we are now back to recording. And we've added a little bit more to our application. We now see how we can store some local variables. We've looked at string and we've looked at int. I did want to take just a moment and look at concatenation. So let's go ahead and jump over real quick to our whiteboard again. So basically concatenation is just allowing us to take a string and append it to the end of another string. So if I was to have a simple program like string first name, I'll just say first. Now I'm putting an R in there. It's being slow. See, told you. And stop with the giggling. String last. That includes those of you in the BuzzNet too. And then actually, you know what? Instead of just declaring, let's declare and initialize. So let's declare and assign. So fist, as you guys like to know it, is going to be known as Bob. And last is going to be known as Jones. So if I wanted to print both of these out together, Nelson, did you want to just take over?
Well, yes.
No, hang on. Let me finish what I was getting at. I saw your fist face. But basically, if we wanted to print these two out together, again, my abbreviated console.write line, we could simply say first plus last. But here's the important thing to keep in mind. This is just a straight append. So that means we would have Bob, and then we would have Jones, but take very special note, character, character, character. The very next character would be where the J starts. So there would be no space between the first name and the last name. Then there's horrible ways to go about doing this, but I just want you to think of all of the possibilities. What if Bob had a space at the end? What if Jones had a space at the beginning? Those obviously would work just fine, but I mean, when we're asking someone to type in their name in the console, we would not want to say, make sure to put a space at the end of your name. But we could say first plus, and concatenate to the end of that. Two sets of quotes, of double quotes, with a space in between, plus, and then we'll do last. So now you're left with, when we get to the end of Bob, then we're concatenating up against the end of that an empty space, so just a space basically. And then the next character we start with Jones. So everybody go ahead and update their, ready check, update their code real quick to concatenate your first and last name together, and go a step further for me. Go ahead and not only that, but when instead of all of these different console write lines, how about just have it write out, I want it to say, you can say full name, colon, space, and then let's say I typed in Jason Busby. It would look like that. And then on the next one, say something like your age is, and then whatever you typed out there. So let's bring in just 2 write lines only. Yes, you sure can, Mary. Let me go ahead and pull that back up. So it's just simply using a plus so that you concatenate. So whatever, in this case, whatever is stored in the variable first, and then concatenate to that a space, then concatenate to that whatever is stored in last. And if anyone happens to be joining into the class late and they hear me say something like ready check, I am referring to the BuzzNet application that you should grab from over in the Member Sponsor Lounge, where the registration for the C# 101 class is at. All right, so we've got probably 75% of the people checked off as ready.
Remember, you can use the 1 minute one to signal that you're working on it, but you need a little bit more time. That's helpful for us.
Yeah, absolutely. Very good, sir. Okay, and we're almost there. And then I will go ahead and...
Yes, it's the clock icon.
Okay, everybody's done. Excellent job. So basically, we should have just simply had, well, I'm just going to cheat here and grab all of this. So we're going to put full name plus, notice in this particular case, I went ahead and put the space at the end of that explicit string, and then I'm going to come in here and say plus, and I'm going to add a space in, and then I'm going to say plus last name. Nice and simple. And then for your ages, again, I'm going to copy, paste that in there, and to the end of this, I shall concatenate age and take out last name. And I can leave my comments there if I want, and I can go ahead and kill out this write line. And so again, the text that I want to print out, so full name with a space at the end, concatenate it to the end of that is going to be whatever was stored in first name. Concatenate it to the end of that will be a space. And then finally to the end of that, whatever is stored in last name. And down here with your ages, same idea. I went ahead and put the space in myself and concatenate it whatever is at age to the end of it. So if I go ahead and hit F5 to run, so first name Jason, what's your last name Busby, and then what is your age? Let's say 28 for today, hit enter, and that's what I was looking for. Full name, Jason Busby, your age is, and the number. Hit any key and returns. Did anybody have any difficulties with that? Or any problems? And for those that are wondering about string builders, or if you're wondering about string formatting and all of that good stuff, we'll get to that later. Remember, we do have true beginners in this class. I think we've already done a pretty awesome job of dumping a lot of content into today's session. Yeah, that would look ugly. Do you typically comment on the same line of code? You can. I'll just let Nelson talk about comments as he started choking on whatever it is, his tongue, I guess.
I don't really want to get into that right now, but generally, if I do, I don't. If I were to leave a comment, I wouldn't put it on the same line. I would put it on the line above or below.
But there isn't.
But that's only if I was.
And there is no right or wrong way. These are remarks being left for you.
The only concern you have to keep in mind, though, is horizontal screen space. I'll generally try to keep that down so that I can see my entire method and all my code without having to scroll horizontally. Obviously, right now we're working in very low resolution. These days, you're going to be working at a minimum of a 1440 by 900 resolution, which would probably fit everything Jason has right now on the same page. But just keep in mind that horizontal screen space, if you have a lot of comments that go off the line, then that will just become very annoying to have to horizontally.
Yeah, that's definitely not making it easy for the person who goes back and reads over the code to understand. I mean, readability kind of diminishes greatly there. So one other thing, let me just throw this out as an extra real fast. You notice how when we're saying, what's your first name, what's your last name, but we're actually reading on the line after. If you guys want to, we can just use rights instead of right line. So, yeah.
And keep in mind that so when Jason types and Jason hits enter, the enter that he is typing is actually being printed out into the console as a line feed.
Exactly.
So that's how the lines do get separated in that case because of the enter key that he hits.
So it just kind of cleans it up. Of course, here we are in a situation again where it just looks kind of nasty. So you might want to put a space at the end of those guys.
Yeah, the only difference between right and right line is that right line appends a new line character at the end.
So again, it's just, in this case, it just looks a lot nicer typing it right beside the question at hand. And there you go. A very simple little program.
Should package that up and sell it. It'd be good.
On the App Store. Call it My Stupid Program. People would love it. Probably.
Oh, I probably would, considering the other. Ugh.
So, yeah, as a matter of fact, we can do a recap right now. Again, so here we are with the class My Program, and inside it, since this is the only class we have in our program, we have to have an entry point of where execution is going to begin, and that is almost always main. So we've got main. As far as static and void, these are things we'll get into a little bit later, so just take it for that at the moment. And then execution is very straightforward. It's very linear. So we're going to start inside of main with execution line by line. We're setting up a place in memory that we are identifying as first name. It's going to hold a string variable, and a string is alphanumeric plus symbols. So this is an example of a string. Then we're going to set up another place in memory called last name. Its type is a string. And then finally, we're going to set up another place in memory that we have an identifier pointing to it called age. And it holds, in this case, it's holding an integer, so a whole number, positive and negative. Then we jump down here. In execution, we're going to simply write out to the console. As you can see, we're using the console class here. We're writing out what is your first name. Now, since I'm using right instead of right line, The cursor is then flashing at the very end of this because we have yet to hit enter. We don't have a carriage return to knock us down to the next line in the console. So then on the next line, execution begins. You can look at it as beginning over here. We're going to start out with a read line. It's just going to sit there and it's going to let the user type stuff into the console. But the moment they press enter, it's going to take everything that they've typed in and it's going to save it over here into first name. Then we drop down to the next. Same exact thing happens down here with this console write. We simply write, what is your last name? And remember, as Nelson pointed out a second ago, I had to hit enter for this read line to actually take the contents that I wrote and stored in here. But by hitting enter, that actually forced a new line in, which is what pushed us down. So when we write out, what is your last name? Same exact thing. We take whatever the user types into the console, and this time we save it over into the variable last name. If I would have had this variable, if I'd have done this, what would have happened here? Anyone? Quickly, anyone? Lag. Forever.
What about me?
Go for it, Nelson. Yes.
Can I answer? I was joking.
Oh. Suzanne's behind me. What happens, Suzanne? What happens? What happens? Make a guess then. And okay. Meta, what's your guess? I have two students in the room. That is helpful. Meta, do you have a guess? Ooh, wait a minute. Say that again. Well, in this particular case, it's going to, if we're doing some sort of algebra, if I did this, if I said x equals 5, and I said, Meta, what's an x? You'd say 5. And then I turn right around and say x equals 15. What's an x? Oh, what happened to the 5? It just got overwritten. So that's what's going to happen here. We're going to replace what was in there. So if we come back up here and we look at, where's my incredible memory? There it is. All right, look at all that memory I've got. So we can see where we had done name down here. And if you remember with this read line, that's my quick annotation for it, we said that we typed in buzz and it got stored up here into our name variable in memory. If I was to turn around again and let's say type in name equals Nelson, as I'm waiting on Photoshop to catch up with me. There we go. So if I type this in, this would have read in whatever I typed. So let's say it was buzz. It stored it in memory. The next line would have executed, which would have written it out to the console. So it would have written out whatever was in buzz, which would have been, or whatever was in name, excuse me, which would have been buzz. Then the next line executes, and it would have simply replaced what was in here with the new string. It just overwrites it. Now, for those of you that know a little bit more about C#, don't worry about sharing all of the intricacies of what's going on. That's how I want our complete beginners to picture what's taking place. We just overwrote what was in there. Simple enough. We won't discuss immutable and all that fun stuff until later. So, jumping back up here to the question that I asked, it's really saying right now, now I've got Resharper installed, that's why it's graying this out, but it's saying that this is really kind of irrelevant because we'll never use this. So let's just run it and see what happens. So build errors. Oh yeah, since we also commented out last name, down here let's go ahead and say last name equals blah blah. So let's go ahead and run it. So what is your first name? First name, Jason. What is your last name? Busby. But remember, last name is being stored in the first name variable again. So let's hit enter. Age, today's age. Your first name is Busby, and that's all we're seeing. Okay, Jason got completely overwritten. So I just wanted to point that out real quick. And Nelson's answering the memory management question. I take it?
Yeah, I mean, I could say it out loud. I don't know if
You can now that I'm done talking.
Okay, somebody asked, blah, 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 would this cause a memory leak, or would it be better to clear the contents by first name equals blank, then reassign? As far as dealing with memory leaks in C#, there is a thing called a memory leak in C#, but it's not the same thing as what you would traditionally think. Basically, think about it this way. All the memory that you ever try to, or all the memory that is given to you by the operating system will be reclaimed when that memory is no longer being used by your program. The garbage collector is a component of the CLR that actually sits in the background and makes sure that once a variable, you're no longer using the memory that is allocated, that it'll automatically reclaim it or give it back to the system. So you don't have to worry about memory leaks in that sense. But you do have to worry about memory leaks in the sense of keeping a reference to memory longer than you actually need it for, because then the garbage collector won't collect that memory. One benefit of a managed language.
That's very true. Okay, so this was a quick introduction to local variables. And so we've seen strings and we've seen ints. There was one more thing that I wanted us to take a look at, and that is the if statement. Just so that you can do some very, very basic programs that are smart enough to make decisions. So, Nelson, I'm going to actually, you feel like talking for a little bit?
Yeah,
all
I
right.
can talk.
Well, let me push this over to you then, and I'm going to let my throat take a break and let you talk about if statements for a simple minute or two.
Alrighty. So we have my awesome program, which I haven't been keeping up with Jason. So let me go ahead and toss a using statement up here. Now, an if statement is a conditional branch. Essentially, now you up until this point, you have written software, right, actual executable programs that executes code on a line-by-line basis. However, you cannot do anything interesting with that. You will need to, at some point, tell C# that you want to check a condition and perform an action if that condition is true or if that condition is false. I'll talk about true and false in a second after we see some basic if statements. But first of all, I'm going to go ahead and set up a basic program right now. I'm going to write int age equals console, int.parse console.readLine. Above that, I'm going to go ahead and do console write a blah, blah. No, I can talk, but I can't type. Blah, 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 enter your age, and let's do console.readKey. Okay, so let's say, I'm going to put this in a comment up here because we're going to do the first step of all program design. We're going to ask ourselves, what kind of program do we want to go ahead and write? What do we want the behavior of this application? And the application that we're going to write is one that takes in your age, decides if it's equal to 42, and then prints text differently depending on whether or not it is 42. And sounds like kind of a useless program, but it'll serve for our demonstration purposes. So we want to say something like, if age is 42, then print your age is 42. Otherwise, if age is not 42, then print your age is not 42. So that's going to be the logic that we want to express. And C# provides us a tool called the if statement, a basic conditional branching, in order to express this logic in this language. Now, we start off with the keyword if. Then we follow the keyword if by open and close parentheses. Inside of this open and close parenthesis, we write an expression or code that can be evaluated into a value. In this case, we're going to write the expression age equals 42. Now, if you're not familiar with this syntax right here, I'm using a double equal sign. This is very different than the expression that we see up here. The double equal sign is a comparison operator. It is an operator that takes in two values, in this case, the left value and the right value. So therefore, it is a binary operator or has two operands. And then it will determine if both of these operands are equivalent. If they are, or sorry, equal. If they are, then it's going to go ahead and take this expression and replace it with the value true. Otherwise, it'll take this expression and return and turn it into the value false. So the next thing we need to do is we need to provide the if statement a block of code. Remember how Jason earlier defined a block of code as something that is owned by the line immediately preceding that block of code. In this case, this block of code is associated with this if statement. And immediately after an if statement, the block of code given to it will execute only when the condition evaluates to true, only when this statement or this expression, however complex this expression may be, if it returns the value true, then this block of code will execute. In this case, I'm going to write console.WriteLine, your age is 42, woo. Next, I'm going to show what we do, or the inequality operator, which is going to be if. So we start off our if statement with the keyword if, followed by parentheses, followed by our expression, which is age does not equal 42, followed by closing parenthesis, followed by a block of code. In this case, we're going to say console WriteLine, your age is not 42. Okay, so now I'm going to go ahead
Spend a moment
and
on the not equals for those that are.
Oh yeah. This stands for
for
not
those
equals.
of you that are familiar with else's, we'll get to them in a minute. We build it up. Go ahead, Nelson.
This operator is another binary operator that works exactly like this operator, with the exception that it returns the opposite result. So if these two things are not true, it will make it a true statement. If these are a true expression. If these things are true, it will make it a false expression. Remember, the if statement will only execute its block of code if the expression provided in the parentheses is a true statement, or true expression, sorry. Okay, so I'm going to go ahead and reset ReadyCheck and go ahead and make sure you guys have this code typed out. I'm going to nuke these comments unless people want me to keep them. Okay. Nelson is clearly not used to writing this much code. Yeah,
I saw that.
If I had Resharper, this would be this would be over very quickly. Okay, and if anybody has questions about if statements thus far, now is a good time to ask them. Otherwise, I'll assume that people are good. And really, if statements are the foundation of writing programs that actually create interesting behaviors. And especially for like a beginner who's never written code before, understanding a program that executes line by line is pretty straightforward. But then once you start talking about conditionals, your mind really has to get used to this sort of thinking. Why aren't your curlies indented for your if statement? The formatting style that I use and I highly recommend is going to be that the indentation of the curly braces immediately following whatever they're attaching a block to is going to be on the same line. Yes, I have seen this. And I will say right now that if we see that, you get minus 10 points on your homework.
Yeah, that's not good.
NATO is apparently sad at that.
Too bad, NATO. Okay, Jen, is everything good? All right, now we're in good shape. Sweet.
All right, so if I run this, we will get enter your age. If I say 3, we get your age is not 42. You'll notice also something interesting is that once this block was not executed. This block was. When this block gets executed, it will return immediately to this statement, whether or not this block happened to have executed. So because if I type in 42, you'll see that the execution merged back into main, and it continued on. So as far as if statements go, that's the basics. You have to think about conditional logic and how these blocks interact with each other with the if statement above it. Now, I did talk about, should we throw in bools?
Yeah, I would.
Okay. I want to talk about what actually goes inside these parentheses, because that's another thing that people get confused on. What goes on in these parentheses is any expression that has the type of bool. Now, we don't see any types right here. Normally, we have, like right here, we see a type of integer. It's explicitly laid out for us. Right here, we don't see any types. We just have to know that this operator returns a Boolean result. But we can do things like this. We can say bool is 42 equals age equals 42. Now, what this is doing is this is creating a variable called is42 that is of type Boolean, and it is assigning it to this expression. And this expression results in a value determining if age is equal to 42. Now what we can do is we can actually we can actually take this code and use it directly inside this if statement. We cannot put age here. If I put age here, or we will get a cannot implicitly convert type int to bool. So I just want to drive home the fact that what goes inside these parentheses has to be of this type. And remember, all variables and all expressions have types in C#. So you cannot put age plus 2, you cannot put a string name, and so on. Now, you can in other languages like C++, where everything can be stuffed in an if statement conditional, but not in C#. It restricts whatever you put in here to be a Boolean always. So is everyone good on that? It's a straightforward concept, but I've seen a lot of people stick things inside of the expression that are not Booleans and then wonder why it turns into an error. So nothing to do with soup.
Catch Mary's question right above that.
Be specific on the parenthesis for what you're expressing. Inside of this, we're expressing some sort of condition, some sort of expression that returns a Boolean result. Now, a Boolean, maybe actually I should point, I think I totally forgot to describe what a Boolean actually does. A Boolean is a data type, just like int and just like string, but it only has 2 legal values. So remember, the legal values of an integer are going to be negative whatever to positive whatever without any decimal points. The legal values for a string is going to be any text. The legal values for a bool are going to be true and false. So we can have a bool true bool equals true, and a bool false bool equals false. These are the two possible values for either one of these variables. If I were to pass in true bool into this if statement, that would be the same thing as passing in true into this if statement, which pretty much makes the if statement useless because it's now no longer making a decision. So just remember, the possible values of a Boolean type are true or false. The if statement requires a Boolean type inside of the condition, and if the Boolean type is true, it will execute this condition, or this block. If it is false, it will not execute this block. Okay, so bool is 42 equals age equals 42. This is saying, now this equals, this is an operator. Just like plus, like for example, I'm sure you're all familiar with these operators. These are the standard mathematical operators. If you remember, I'm not going to necessarily talk about them in the context of C#, but in the general sense, these are operators that perform some sort of operation on two other things and then return a result. So for example, speaking purely in mathematical terms, 5 plus 5 is an operation. The operator is plus. The values passed into the operator are 5 and 5, and the result is going to be 10. The same is true right here. The operator is the equality operator. The values passed into the operator are age and 42, and the result of this computation is going to be either true or false. True if age equals 42, false if age does not equal 42. All right, are we good on questions? There's a lot of text.
Yeah, I mean, overall, yeah. We'll be getting to the homework in just a few minutes.
Yeah. Okay, so I'm going to go ahead and replace this with that and delete these two lines.
So Mike had a question in regards to, so is 42?
We'll read either true or false. Yes, but remember that true and false, these are keywords. These are keywords that turn into a very specific value. These are not numbers. These are not strings. These are not decimal points. These are not objects. These are not type. Well, there are types. They're variables of types. But these are keywords that turn into the literal true or false. They have no meaning outside of the fact that they are defined as either true or false. Some languages will treat the value true as 1 and the value false as 0. Also, some languages will allow any expression that turns into anything but 0 to be true, and any expression that turns into a 0 to be false. C# is not like these. Think of these like atoms. They are specific values, specific keywords that only have meaning in and of themselves.
You still there, Nelson?
Okay. Yeah, I'm just trying to read through the comments. I really need to make that look better. Is it better to use 0 or 1 rather than false and true? It's not possible to use 0 or 1 in C#.
We have to use true and false.
Florum brings up a good point. That's more to do with when we get into talking about expressions, because expressions are very important to understand where they're used and what can go in them. But he brought up the point that couldn't you just do this, and would it affect performance? And the answer is yes and no. As in yes to the first part and no to the second. You can do this, and it does not affect performance. It does look a bit nicer, though.
Okay, so you want to go ahead and point out that, of course, in the block of code for the if, they can have multiple lines. They're not just limited to one.
Oh, yeah. So you can type in as much code as you want in these blocks. Okay, so the next thing, I mean, are we good on if statements? Because I do want to just at least talk about else statements, and then
Yeah,
I guess unless you wanted me to cover anything more.
Once else statements are covered, that's it.
Alrighty, so if everybody's good on if statements, then we can go into else statements. Okay, so this is a common pattern in programming, a very common pattern, where we will say if this statement is true, then perform these actions. If this statement is false, perform these actions. And the reason I say if, this is kind of getting confusing, because this is actually going to evaluate two true, but it's still the opposite of what we had in the previous if statement. So instead of typing this out, what we can do is type in the keyword else and simply provide another block. You'll notice when I type in else, the Visual Studio is going to highlight the if statement that corresponds to this else statement, and that's very important. An else statement cannot exist on its own. It must exist immediately following the block of an if statement. So yes, so an else statement will simply be the block of code that is executed if this particular state expression was false. So if we were to run this and enter the age of 51, which is not 42, we will get your age is not 42. So else statements are very straightforward. They're just basically going to execute if the corresponding if statement is false.
So with that out of the way, Nelson, do you want to spend a minute talking about the vending machine?
Yeah. I wanted to, well, I mean, should I do pseudocode for this, or should I just explain it?
I would say just explain it. In fact, Gavin,
well,
we're not getting into, we're keeping it simple right now. So go ahead, Nelson.
Hold on, some questions are coming in. What about the if not 42? The same thing as false, right? Yes, but that's a unary operator. Okay, so the vending machine is going to be a basic program that the concept of the program is that it will start off with a predefined amount of money allocated to a person. And that money is going to be in rounded dollars. It's not going to be, we're not going to deal with cents. And you start off with a predefined amount of money, and then the program asks you to make a particular choice as to what's available inside the vending machine. Which means
it's going to need to present you with a list of what's available in the machine and how much each.
Yep. And that list, as long as you, let's just say a minimum of 4 items, and what's in the vending machine isn't important. Just to say a minimum of 4 items. And then it asks you to select one of them. And every item has an associated cost. When you select an item, after you select an item, the cost of the item you selected will be deducted from how much money you started off with. And then finally, what the item you purchased and how much money you have left over will be presented on the screen, and then the program will terminate after a read key.
And yes, this is the homework that's being created for this class session. It's very simple, again, with the complete beginners in mind. which we will still have beginners struggling with this.
Yeah, that's a good. Segfault brings up a good point. Do you want me to show subtraction real fast? An integer supports the subtraction operator as well as the addition, division, multiplication, and a few others. So, for example, we could say int money equals 53, and then we can say money equals money minus 3. What this code is going to do is it's going to stuff the value of 53 into memory and name it money. And then it's going to immediately, the next line, it's going to replace whatever was in money previously with what is in money currently minus 3. And the result will be 50. So is everybody good? You're going to need the subtraction operator to do the math required, but it's a fairly straightforward operator. I could pull up a more, intense example if anybody needs me to. I think right now you wanted to handle homework assignments with email.
I want assignments to be sent to busbyj@3dbuzz.com. Preferably just zip them up.
FatGav has a good idea. What do you think?
I didn't see it.
Write out what you would expect to see in a console and the typical use. Okay, so imagine this is a console window. So it says, blah, blah. It's going to say, hey there, you have X dollars, or let's make it more concrete. You have $30. Please select an item.
Don't you want to maybe number them?
Oh, yeah, we could do. I was thinking about doing string compare, but we could do number as well.
Since they know how to do that.
Okay, and then I'm going to, well, first I'm going to get rid of these because they kind of conflict with that. Then I'm going to simulate keyboard input with a forward greater than sign. So this is what the person would be typing. They would type 4. Also, these need $3, $2, $5, $10. And then it would say something like,
and since we're not doing looping yet, that's just a one-off. You'd have to run the program again to.
Yep.
I believe we're going to get to looping in the next class. So very, very simple. Most of you guys can have this knocked out in 5 minutes or less after class. About that.
This is conceptual. Why would a vending machine know how much money I have? Give it time. Once we have RFID chips embedded in all of us, the vending machine will be able to query query our banking
Hey,
names.
I have no problems, and I'm sure Gavin wouldn't either, if you wanted to make the program a little fancier and have it start off by saying, how much money do you have?
You could, because then you would have to account for if the item you purchased was less than how much you started
I kind of
with.
like that, because then you could test out not having enough money and trying to purchase things that you can't afford. And Gavin is saying, for those of you that can't see, extra credit for multiple uses too. Gavin, you're the TA. If you have anything you want to throw in there. Gavin likes to be impressed, guys. So anything else that you want to add in, Nelson?
I guess we can go over generics.
Nice joke. You know, it's not a bad idea to consider a forum. We'll just have to. We'll talk about that. A place for them to ask questions.
Yeah. I mean, there's always the C# forum, and people who aren't member sponsors will be able to answer questions there too.
Just don't go posting all of your source code in there.
Yeah.
But I think that's going to pretty much wrap it up for now. If there's no other questions, apologies for the class running so long, but expect that, I guess.
Yes, there is a C++ course planned in the future.
Yeah, hopefully we'll have details out on the C++ for our course not too far off from now. Yeah, it's no, JT. That was a good joke. I liked it.
I seriously thought he was
and when
asking
you
that
said
question.
what you said, I thought it was serious too. So I was, looking at the keyboard, ready to give, It scared Mary. No C++ for this gal. It scared me horrid. Come on, C++ isn't that bad. Okay, yeah, it can be. It can be.
Very much so. It would be like course 5 or 6 by the time we got to doing this, especially when it comes to like strings and stuff and concatenation. Oh no.
Oh, come on. Okay, well, let's go ahead and wrap it up again. Thank you guys very much, and for being patient with us as well as we were, working out some of the kinks at the very beginning of this. We will continue to get the bugs worked out of BuzzNet, because that will become a requirement. If you are running a Mac environment, we will, sometime coming up soon, have a Mac build for it, though I really do recommend taking a look at something that will enable you to run Visual Studio 2010. There are a few different ways that you can go about doing it. Nelson, you want to talk about some of those?
Well, yeah, you can always. You know what's going on right here. I'm not entirely sure how to get out of full screen mode, because I told it to get the to remove the. Oh, there we go. What you've been seeing this entire course on my computer is actually a virtual machine. So you can go ahead and grab like a free virtual machine program, like a VirtualBox or something, and throw a Windows 7 install on it, and then you'll be able to use Visual Studio just fine within a Mac. Also, there's Boot Camp, which is another one for booting into Windows, although I understand that people who are used to Mac might not appreciate that as much as a VM window.
True.
Hey, there's my participate button.
Hey, there it sure is.
Yeah, it wasn't designed to work with presenters.
Good point. Okay, so just looking over here for anything, any last questions coming in?
Do we email the CS files or the executable?
CS files only,
please.
no executables.
The CS proj and slin are fine too. So if you just want to grab the entire folder and zip it up.
No, NATO, come on. This is not where tomorrow you try to do the assignment and your brain falls out. It is not that bad. Exactly. Gavin will not be running any executable files that he has sent. Toastich has a dumb question, my favorite kind.
If you wanted to assign a name and a price, would you create 2 separate variables? I'll give you extra credit if you can find a way to do it with a single variable.
You?
I'll take that back because that you
No, he will try.
Well,
his support code for it's going to be a little more interesting.
Yeah.
But you said extra credits. He got really excited. I think that's good. I know Toastich. He loves doing things above and beyond.
Yeah, he'd have to learn about strings and all
that's what I mean.
He's
going to have the support code to deal with it.
How can I find out what homework is? It'll be posted in the forums, I believe.
Okay. So that is going to wrap up. Wolf, Nightly, were you also not listening when we went over the homework a minute ago? And did the example, the pseudo printout? No spacing. What's up with that? Okay, yeah, it's probably late where you're at. All right, yeah, we'll get this to you guys over in the forums. Thanks again. We do appreciate it. Again, Thursday night, feel free to join if you would like to. It's going to be the same exact thing, except heavens knows my drawings will probably end up looking a bit different. And, well, the content will be the same, but all of the actual material will probably alter. Hang on one second. Gavin, you just sent me a question. So this is a TA question, actually, for this. Okay, hang on. Gavin wants you guys to PM him the homework. So Gavin, put your username over inside of BuzzNet real quick. We'll also add that into the post over in the Member Sponsor Lounge for this homework. So FatGav is where you will be PMing. So basically, you're just going to copy and paste your CS file. You don't even have to worry about the zip. You can just highlight the code, Control-C, and then go over and do a PM to Gavin and Control-V. No, you don't have to send it to my email address. Gavin's just trying to come up with an easy way for it to be delivered straight to him. But if anybody misses that, it's not a problem. We'll make it all work. So again, you don't have to actually send the CS file. You can just Control-C or Control-A, highlight it all, Control-C to copy it, and then paste it over in a PM. Yeah, Gav, make sure your PM box is empty. All right, well, we'll get all this information up in a thread for you guys. Thanks a lot. It's been a great class, and I'll see some of you guys again Thursday night. If you have any questions, feel free to post them for now over in the Member Sponsor Lounge or the C# Open Forum. It's open for everybody. You guys have a wonderful night. Bye, everyone.